Think can happen in the next half hour.
Don't.
I was going to say we can't sing.
I was
Okay.
going to say, I still, every time I hear somebody say that, I still think of the time that one of our corporals actually managed to
Think can happen in the
convince
next half hour.
two young, two young, two young Scopies that the siren they heard was the alarm for the building going underground, like in Stingray, and that they couldn't leave, and that he then pointed them into our restroom and left them there.
Oh,
And we
bless.
got a very irate phone call from Warrant Officer Ops a little while later. Where the hell are my airmen?
They're just waiting for the building to sink into the ground.
Yeah. Apparently, it wasn't a very popular move.
Miserable buggers.
Hey, I suppose the best one was when Brian, our watch sergeant, stuck a couple of pencils up his nostrils and answered the phone to the master controller with "Wibble"
Wibble.
and promptly hung up.
I'm assuming, Terry, that we're live.
Yes, we are.
Thought so.
What gives you that idea?
The fact that we're live.
Yeah, the fact that we can see ourselves on the live stream.
Oh, amazing that.
Always a bit of a
Technology
giveaway.
these days. Go figure. We've got the usual peanuts, penguin, surf, Dora, cakes, M2M. I still prefer Space Mat. It rolls off the tongue a lot better.
Yeah.
AKA M2M. Or M2M, aka Space Mat. And he did a video. I think he said he did a couple of videos. Or he's going to do a video.
He's got another premiere today.
Oh, okay. I'll be asleep by then. Unless it's early hours of the morning.
So,
I don't know. Not me.
what?
Noises.
Sorry, am I typing loudly?
Was that typing?
Blimey. What, using a
Well,
lump hammer?
at
Somebody
least,
banging a desk or something?
at least I wasn't heavy breathing this time.
Oh, yeah. Gosh, if I got any heavier, we'd expect to heard, I am your father.
And the breathing as well, yeah.
I am your father.
Things. I knew I should check things before we go live. A couple of little things a little bit tweaked. Out of order. I'll know when Paul goes to do his thing if it's okay.
Oh, right.
Oh no! Look out!
How will you
I
know?
see a duck.
You see a
I
duck.
see.
Oh,
I see
yeah,
Harvard students.
Yeah, Harvard students.
I see a duck. It's over there. See it? Just there.
This is feeding time at the Harvard place.
Oh, okay. And I gather we got a celebrity, but have we got a clue for him?
Haven't got a clue yet, have you? No. I haven't given a clue yet.
I ain't got a
haven't
clue
around to
anyway.
So you haven't got a clue.
Let's formulate a clue.
Yeah, come on in casual and stuff your face and talk whilst you're eating. That's always a favourite of mine, yeah.
I thought he was on a diet. And I'll eat something just for farmers. He likes that. Okay.
Yeah. Well, he was forever eating, wasn't he? He said every stream he was in, whenever he started talking, he got a mouthful of something. And I'm afraid when you've got headphones on, you can hear everything.
Yeah.
That's why I prefer the remote-mounted microphone that I use.
Mm.
Only trouble is, it seems to be able to pick up the keyboard. Mind you, my keyboard is really loud.
Yeah. Well, I'm glad I'm sitting down because I've just had a mild moment of shock.
Oh.
What's that?
I know who that is.
Oh. Oh.
Well, type it. Well, type it in the inside
Wow.
chat. Yeah.
I can't quite believe that. It's like, hang on a minute.
My underscores came out as brackets for some reason in the text chat. I don't know why. I must have shifted my finger as I was typing.
So this French scientist and philosopher was a very influential mathematician and an expert in hydrostatics.
It's the hydrostatics that gave it for me.
Oh.
Strangely enough, given my profession.
Yeah, I couldn't get the first name, but at least I got the second.
Ah.
You were correct, Farmer's Boy, and so is Dora Nu.
In fact, given my profession, I think I should have been ashamed of myself if I didn't know that one. There's 100,000 of them in a bar.
Yeah.
Is there?
Yes, there's 100,000 of them in a bar.
And one
Just,
walks
just
out,
the same
right?
as peanuts.
Is that how the joke goes?
Yeah, that's what I was just going to say. That sounds like a joke.
It's what one of our lecturers always used to say at college. He used to compare him to a marathon bar.
101,325 to be precise.
Well, I know, but when you get to those sort of numbers, it's close enough.
Mm. I know the name of the answer, but I wouldn't have guessed it by the clue.
It's one of the units of pressure.
Yeah.
And it's a horrible flipping computer programming language.
Oh yes, it is, isn't it? Yeah.
Yeah. First year at university, they made us learn Pascal. Then in the second year, we had to learn C so that we could actually do all the programming in all the other courses that we had to do in the second year. So I never understood why they bothered teaching us Pascal in the first year.
And it was named for him. Well.
3 holes in the ground.
Yep. So what's going down then, Terry?
The topic. I know there's been a lot of talk over the water cooler over in Discord about a certain pilot, but we'll get to that in a minute.
Cool.
If a lot of people have probably heard about that by now. Anyone out in the peanuts see the thumbnail to see if they can guess what tonight's topic is? Or subject matter?
I haven't even had a look at the stream thing.
Yeah, well, it's usually the peanuts will see it before they goes live, so they're lucky they... How come I'm not getting any YouTube notifications in my own YouTube channel when you go in
What,
there?
you don't get notified when you go live yourself, Terry?
No, it's not showing up in the YouTube that I'm going to go live. Like it's not showing that I've got one set up.
No, it did for me.
No, in
and
my
I've
own
just,
YouTube. No, in my own YouTube channel, if I go into videos, it usually has scheduled or whatever, something like that. I thought that's what it used to do.
Don't know. Well, obviously, it's showing you live now. Oh, Elmigs! How could you dare write those 3 words?
The RDD. Cake's saying survey. I think that's supposed to be
Geodetic surveys.
Yeah, surveys. Any other guesses? Cakes is lukewarm, I suppose.
Sort of in the ballpark, I guess.
Yeah. A couple of those instruments, well, one of them should be a bit more of a clue than the other one. I think one of the images on there. Have I got? Okay. I'm not getting any other guesses out there. There's a few watching, so we should be able to get some guesses. So Mum Bakes Cakes is in the field, so to speak. I'm lost. Why are you lost?
Why? Where did you think you were going? You know, you should have turned left at Albuquerque.
So if you're lost, what would you do about it?
I would take out my map and compass and do a resection.
Take the map off the wife and read it myself.
Yeah, I used to have to keep waking my navigator up back in the days when we didn't have sort of GPS and Google Maps on our phones. She was my navigator, and 9 times out of 10, out of the 4 people in the car, I was the only bloody one that was awake.
Of course you were.
Wake up, tell me where we're going. Yeah, of course I was. I was driving, yeah.
Yeah.
Let's see if I can find the image.
Apparently, yesterday was the anniversary of the promulgation of the Longitude Prize by the Admiralty in 1715. No, 1740. Oh, shit.
Whenever.
1715, I think, or 17, maybe 1745. Bloody memory keeps playing tricks on me.
I can't.
Then that helps. We can actually see it because obviously I can only see it until I click on the thumbnail.
I don't know what's going on here.
Well, I think we're seeing a.
Yeah, you're seeing
because-
something, but I can't close the window, and I've lost the. I did it the wrong way. I have to stop sharing. It's supposed to go over here. I'm going to do that again. Where is it?
Non-Euclidean perspective. Oh dear. Did anybody happen to hear Bev in Jose's hangout yesterday? He seems to think that he knows more about surveying than the Ordnance Survey, which was quite something.
Alright, try again. So if I bring it over to here, minimize that. This time we should be able to do it.
Oh dear.
I don't know which is a better. I think they can see it out there.
I think we can guess what you've got there.
Yeah, there we go. I just had to make it a bit smaller. It was a little bit too big. I don't know if there was an actual legend that went with this. I'd have to go back onto the page to see if there was, but
yes, because they're all lovingly labelled up, aren't they, as Fig whatever.
Yeah.
Yeah, it is. I did get it from one of those documents that's out there.
I'm gonna suggest the big large item in the top right corner would be a sighting compass.
Ah, there is a legend. There is a key to each of those items.
Yeah, it says figure whatever on each one, doesn't it?
Yeah, well, when you go to that web page, there is a list. There are 13 figures in all.
Oh, thanks for that, Farmer, because I was trying to figure out how was I going to get to that and bring that, get that around to.
Which of the?
So you read them out. Any way to read them out? If there's is there a number or a letter next to each figure? And
well,
next to each.
I'm just going to save.
I was going to say which
is which?
Which was the? Which link is it?
It is.
It's one of them.
It's the, right, Alan. It's the very last link in Stream Topic.
Yeah. Okay.
Right now, I've got that. I've downloaded the picture and opened it up so that I can zoom into the bloody thing, so I can actually.
No,
read.
it ain't.
Right.
It's not the very last one in Stream Topic because I just clicked on that.
Right. That disc-shaped thing in the top left is figure 1, which is a compass card, and the diamond-shaped thing next to it, figure 2, that's a compass needle. Now I can't see. Ah, right. Okay. Do you want me to go through all of these, Terry?
Yes, please, Farmer. I've got the images on the screen so they can...
Right, the image is on the screen. Right, so figure 1, top left, figure 1, that's a compass card. The circular thing is a compass card. You can see all of the various numbers going around the outside that are all in
degrees.
Yes, but they're all in Roman numerology.
Oh, okay.
Zooming too much. You can't really read it anyway because it's just not that high. The diamond shaped thing next to it is the compass needle, so that would sit on top of the compass card. And if you go down towards the upper middle, there is a drum looking thing. That's figure 3. That is the complete compass. And the box shaped thing sitting on top of it, sitting above it, figure 4, that is an azimuth compass. Figure 5 below the compass card, figure 5 and figure 6, you've got a sea astrolabe.
And Nelbig's actually hit the nail on the head with the topic. Only after we started reading.
Yeah. And next to that is a brass ring or circle. Quite what that's for, I don't know.
Okay.
Right, the fan-shaped looking thing below all that, a figure 9. That is that's illustrations of cross staff use. And I'm just looking for whatever where's the cross staff? Where's the cross staff? Yeah, some of this is getting the job to read now. Right, if you go below figure 9, which is that fan looking thing, if you go below that one item and then a cross, that's figure 8. That is a 4-staff or cross staff.
With the 4 vertical.
Yeah, with those 4 vertical doodads on it.
Yeah.
The angled thing that's next to it, I can't read what the figure is. It's too blurry. Figures 10 and 11 don't have a description, so I think that might be figure 10. I think that's just showing again how you use the cross staff. The big item down in the bottom right hand corner, figure 12, that's an English quadrant or backstaff. Obviously down in the bottom left hand corner, that's a semicircle. Well, that looks pretty much like a protractor.
Yeah.
Not sure what the little figure above it is. That's not listed or described.
Okay.
And what haven't we covered? Figure 7. Figure 7 is the one next to the complete compass, and that's a quadrant.
Okay.
And you can see there's it looks like it's got a little plumb line hanging down from the top of it.
Yeah.
Yes. And that's about it, I think.
Yeah. Oh, thanks for that.
That's all right.
I'll stop sharing that now. Now that they've figured out what the topic is. With a bit of help.
With a bit of help.
Okay, I'll get rid of that for now. Right, that brings us up to this guy.
That guy?
No, this guy.
Okay.
From what the research I could find, I don't mind being proven wrong or corrected, but this guy, and I'm not even going to attempt to pronounce his name. If anyone wants to have
a go. What name it is? That's quite something, isn't it?
I looked at it and I went, oh shit, what am I going to do here?
Abu Mahmud Hamid ibn al-Qidra al-Kajandi, known to his mates as Al.
Yeah, okay. Yeah.
Probably.
You can call me Al.
Yeah. Hey, Spook. Well,
hey.
So going through all the navigational topics that I was looking for, because I started off with the sextant, and I thought, well, okay, we had to have gotten to the sextant somehow. So going back into what I found, I found this guy, and this was about 940. So I thought, okay, this is going back a bit. I'm sure they would have used other methods, but I thought, okay, well, we're not going to find a lot. So I thought, okay, we'll find this guy then. And and as I've mentioned before about over in Islam, over in that area, a certain time period where they were um, getting advanced or were advanced in their mathematics and science, and then it all went downhill for some reason. Imagine what they'd be like today if they'd kept up with what they were doing.
They had apparently the imams had a change of heart over what was acceptable things to do, and all of a sudden, where science had been a very acceptable thing to do, it was no longer allowed.
Yeah.
But they were ahead in a lot of fields.
Yeah.
Oh yeah.
Yeah.
Yeah. Way ahead.
Way ahead.
But religion.
Except
God said.
Yeah.
Then religion happened again.
Yeah, again.
Well, yeah. God, the people in charge decided God said.
Yeah.
It's all their really good stuff happened sort of before about 1200.
Yeah.
Did you bring a friend, Spook? Where are we? Yeah, I fixed them, Dora. As long as they've subbed, because it costs you a spanner. So the summary, Al, we're not going to try to read his whole name, was an Islamic astronomer and mathematician. He made accurate astronomical observations and may have made some advances in trigonometry. We can read all through this if we like. There is some information amongst it. How far does it go? It's not a lot. Can I make it bigger? Why do people type so small? Can I make it a bit bigger for me? That's the only thing. Where have I got that? Yeah, I can't go much bigger because it won't fit in the screen. I can just barely read that myself, so I'll read a couple of paragraphs and then my eyes will just go completely watery. Okay, biography. Few facts about Al's life are known. I'm just going to call him Al. What little we know comes through his writings, which have survived, and also some comments made by Nasser, that guy. From Al's comments, we can be fairly certain that Al came from the city of Kujand. The city lies along both banks of the Siradara River, at the entrance to the fertile Fergana Valley, and it was captured by the Arabs in the 8th century. Al says that. Oh, okay, there's two Al's here. We can't have two Al's. Al-Tusi.
Sorry, the problem is I think the Al-Kujundi just means from this place.
Yes.
That's why you've got Nasir al-Din al-Tusi, because he's from Din and Tusi, I would guess.
Okay. Al-Tusi says that Al-Kujandi was one of the rulers of the Mongol tribe in that region, so he must have come from the nobility. Al-Kujandi was supported in his scientific work for most of his life by members of the Buyid dynasty. The dynasty came to power in 945. That'd be, what do they call that now? There's a new word for it. When
first century, first millennium, end of the first millennium.
Yeah, but it's BCE now and not AD.
No, this is
BC nowadays.
This is No, that's what they would call
Common
current
Era.
epoch.
Common Era. That's it. CE. Yeah. When Ahmed ad-Dawla, forget it, occupied the Abbasid capital of Baghdad. Members of Ahmed's family became rulers in different provinces, and there was never a great deal of cohesion in the Buyid Empire. Al received patronage from, that name. Fuck you, ad-Dawla. What?
Fuck here.
Oh, sorry.
Yeah.
Fuck here.
Sorry.
You got the swear jar out, Terry?
What? That's what it said. Who ruled from 976 to 997.
Oh dear.
Did I mispronounce
Do you-
that?
Do you want me to take over, mate?
Yeah. My eyes are just starting to.
No worries. Let's have a go at these the Arab names. It was Fakir ad-Dawla.
Yeah, that's
who
what I
supported
said.
Fakir, not fuck you. Who supported Al-Qajandi in his major project to construct a huge mural sextant for his observatory at Ray, which is near modern Tehran. It was believed by many Arab scientists that the larger an instrument was, the more accurate were the results obtained. In fact, Al-Qajandi's mural sextant was his own invention, and it did break new ground in having a scale which indicated seconds, a level of accuracy never before attempted. Just think they'd only worked in degrees up until then. During the year 994, Al-Qajandi used the very large instrument to observe a series of meridian transits of the sun near the solstices. He used these observations, made on the 16th and 17th of June 994 for the summer solstice and 14th and 17th of December 994 for the winter solstice, to calculate the obliquity of the ecliptic, and the latitude of Ray. He described his measurements in detail in a treatise on the obliquity of the ecliptic and the latitudes of the cities.
Say that three times fast.
Yeah. What, obliquity or ecliptic?
Both. Farmers, remember, they would have been working in degrees and minutes before they were working in degrees.
Oh, that's right. Yes. Sorry. Yeah, I forgot about the minutes. Yeah. From his observations, he obtained 23 degrees, 32 minutes, and 19 seconds for the obliquity of the ecliptic. This value was lower than values obtained previously. Al-Qajandi says that the Indians found the greatest obliquity of the ecliptic, 24 degrees, Ptolemy 23 degrees 51 minutes, and himself 23 degrees 32 minutes 19 seconds. These divergent values cannot be due to defective instruments. Actually, the obliquity of the ecliptic is not constant, it is a decreasing quantity. I don't know what's worse, this or the Arab names.
So accuracy to 1 degree, to 1 second of arc is you're accurate to 1 in 1.296 millionth of a circle.
Yeah, that's pretty good going, isn't it? Considering we're talking, when was this? 994.
So, yeah, over 1,000 years ago.
Yes, well over. Yeah, not bad at all. Right. There is, however, an error in Al-Qajandi's value for the obliquity of the ecliptic. It is about 2 minutes too low. The error was discussed by Al-Biruni, and we all know who he is, in his Tardid, where he claimed that the aperture of the sextant settled about 1 span in the course of Al-Qajandi's observations due to the weight of the instrument. Al-Biruni is almost certainly correct in pinpointing the cause of the error. However, Al-Qajandi's latitude for Ray, 35 degrees 34 minutes 38.45 seconds, despite being calculated using his erroneous value for the obliquity of the ecliptic, is accurate to the nearest minute of arc.
That will generally get you there, won't it?
It would. It would definitely get you there. Yeah. So well within well within any error margins.
Yeah, I mean, I think that gets you into something like 100 meters, so 100 meters square ish.
More accurate than the Americans when they were bombing Berlin in World War II. If they got within a mile or two, they were doing well.
I could, yeah, okay.
Yellow. Right. It remains for us to discuss, so let's discuss, the claim that Al-Kajandi discovered the sign theorem. The claim was made by Ozzie, who gives Al-Kajandi's proof of the result for spherical triangles in his Shakal al-Katra. Although there is no reason to doubt Ozzie that the proof he gives does indeed come from Al-Kajandi, there is quite a few reasons to believe that one of Abu al-Wafa or Abu Nasser Mansur was the original discoverer. Why couldn't this be done in Europe? Blimey. I mean, I've got nothing against them, but their names. Good grief. Well, hang on, no, it could be worse. It could have been Polish.
Yeah.
Right, really there. Both Abu al-Wafa and Abu Nasser Mansur claim to have discovered the sign theorem, while, as far as we are aware, Al-Kajandi makes no such claim. Also, Al-Kajandi was more of a designer of astronomical instruments and an astronomical observer than he was a theoretician. Finally, although this really proves little, the theorem appears many times in the writing of Abu Nasser Mansur, both his writings on geometry as well as those on astronomy. We should make one final comment on the mathematical contributions of Al-Kajandi. He stated Fermat's last theorem in the case n equals 3, although not surprisingly, his proof is wrong. Al-Kazin wrote, I demonstrated earlier that what Abu Muhammad Al-Kajandi advanced, may God have mercy on him, in his demonstration that the sum of two cubic numbers is not a cube, is defective and incorrect. It is certainly interesting that Al-Kajandi, despite his practical rather than theoretical achievements, should be interested in this number theory result. Yeah. Repeat after me the obliquity of the ecliptic.
Yeah, isn't that something we usually hear coming out of Lindsay?
Yeah. That's when he waggles his arms.
And we all wait for that 23-minute mark and something seconds.
23 minutes and 15 seconds, isn't it?
Something like that, yeah.
It's 27 minutes and 13 seconds.
I couldn't remember.
You haven't watched enough Lindsay. Damn.
No, I've watched too much Lindsay. I'm telling you now, I've watched too much Lindsay.
Okay.
Well, there you go. You can call me Al.
Okay, Al.
Okay.
Stop confusing me.
I won't call you that fuck you name, bloke.
Yeah, fuck here.
Oh, fuck. Yeah, I said that.
Or fuck there. I don't know. Ironically, we kept saying, just call him Al. We should actually have just called him Abu.
Yeah, that's what I said at the beginning.
Yeah.
Never mind.
But that's, well, it's difficult to remember that. Every time you read, an Al-Tuzi or an Al-Kajandi, that's what you just tend to go with.
Yeah, I know. Even though it just really kind of implies where they come from.
Yeah.
Hey, have you seen what Dora's just suggested? Vote if you want to know more about mathematicians from Tajikistan.
Mm-hmm.
Well, that's a toughie. Do I want to know more about mathematicians from Tajikistan? No. Not if I've got to keep reading their bloody names out.
Death wants to know where Blue is. Blue's here. Where else would he be?
He's there, look.
There, you can see him.
Yeah.
Wave, Blue. See, you can stick your hand up. Look.
Hello.
Yeah, you can do.
Hello.
You can do this. There's this thing here somewhere. Oh no, that's clap. No, I don't want to give you the clap.
Oh no.
Isn't there a wave thing? Oh, you can do a thumb up like that. Oh, that goes there. Oh, wrong place.
Yeah.
I know you can do it.
Yeah.
Yeah, on your thing you can Yeah, I figured it out the other day. Now I can't figure it out what it was, where it went. Anyway. Oh, reactions. Here it is. It's on the bottom of your screen. See? I can do wave like that. There we go. Yeah, that's it, Blue. He figured it out there. Yeah, reactions. We can do that to people.
And the Elmigs, no, I am not binge watching Lindsay's channel.
Oh, no. No.
No,
No.
no,
No.
not a bloody chance.
Okay,
S-
I'll share
So I
my...
don't,
I'll share in here while you're talking. Because we need to know where we're at now. So we got that one. I'll just make it a bit smaller. It's that. These are just all the ones I grabbed. So there's that. Oh shit, what was this one? That one. That one. This is the one I got the picture of. That's where you got all the legend thing from too, wasn't it? Here somewhere.
There you go. Yep, there's the legend.
Yeah, that's the legend thing. I'm just wondering if this bit might be a thing to read. The introduction, and because it gives you X, Y mapping, coordinates, celestial objects, you know, bits and pieces there.
Oh yeah.
That's that one. Ah. Yeah, okay. Yeah, we don't want to jump ahead too quick to that one. So maybe we might read a bit of... this one's going to be a bugger, isn't it? To read.
Yeah, I've got it open on the other screen and I've had to zoom it in a bit as well.
Yeah, I know. That's what I'm trying to figure out what to do here. So I can make it bigger there.
Yeah, that's probably. I think that's as big as you'll get it.
Oh no, it cuts into the side bit. Then we lose that bit. I don't know if that bit at the top's actually relevant at the moment. Because where I got this from, Table of Contents Explorers, I don't know, it's just something I found just searching for whatever words you type in is what comes out. So I think we could just read from here. I think it wouldn't matter the bit at the top.
Yeah.
Okay.
Yeah, I think that bit doesn't really add to it.
Two developments in scientific marine instruments in the last half of the 18th century led directly to much more accurate mapping, hence more reliable navigation and more systematic exploration. The sextant, John Bird, 1757, for determining latitude, and the marine chronometer,
chronometer.
Chronometer. John Harrison, 1761, for determining longitude.
For which he should have won that prize.
Yes.
Latitude and longitude are the X and Y of mapping. The coordinates of a place's address. The sextant followed in an evolving line of instruments: quadrant, astrolabe, cross-staff, backstaff, octant, designed over the centuries to obtain one's latitude, or angular distance north or south of the Earth's equator. English instrument maker Bird improved on the octant by expanding its scar range from 1/8 of a circle, 45 degrees, to 1/6, 60 degrees, hence the sextant's name. There you go. So you didn't know that, did you? It was truly a point-and-shoot device that divided the field of view into two, one for the horizon and one for the celestial object. By moving the index arm of the instrument until both images were aligned, the celestial object just touching the horizon One then could determine the angle separating them by reading the pointer on the scale of the arc. The ship's movement on the sea had no effect because both objects moved together.
Yes.
A sextant was accurate to about 1/5 of a minute, given that a minute is 1/60th of a degree, or about 1 nautical mile. The instrument's accuracy translates to latitudinal readings that are within approximately 0.2 nautical miles. Measurements were taken at noon using the sun or at night using Polaris, the North Star, which indicates true north and does not move, for it's aligned with Earth's rotation. With sextant readings of the sun, the tilting of the Earth's axis, the sun's angle of rays at the equator, or its declination, has to be taken into account. This angle changes throughout the year, from 0 to 23.5 degrees, as the Earth revolves around the sun, depending on being north or south of the equator. One would have to add or subtract this declination to obtain an accurate latitude reading. In Cook's time, there were published declination tables for each day of the year. Sextant readings of Polaris to determine latitude in the northern hemisphere were more straightforward. If Polaris is 10 degrees above the horizon, one's latitude is 10 degrees north. It is no coincidence that Captain James Cook, the man considered to be the best navigator of his time, had the advantage of using sextants on his 3 historical voyages. Otherwise he wouldn't have found Australia.
But that was by the by, wasn't it? Finding Australia. I mean, he was sailing out into the Pacific. What was it? What was he? Oh, it's Venus, wasn't it? It wasn't the transit of Venus. That was the whole point of his first round the world voyage. Was to observe the transit of Venus.
We're going to run into a bit of problems here.
Why is that?
Because I can't get it any smaller to fit it in. I mean, I can get it smaller to fit it in. There we go. There.
Would you like me to read a bit?
Because there's no way I'm going to be able to read this. I mean, I could try. Note, however. Yeah, okay. Who wants to volunteer? Put your hand up if you're volunteering.
Alan's going for it by the sounds of it.
I'll go for it. I've already got my hand up, haven't I? Or I thought I put my hand up. Yeah, my hand's up. Look. Hang on. Right. Note, however, that latitude defines circles around the Earth, not points on them. For that, one also requires longitude, the angular distance east or west of some predetermined prime meridian, which circles round the 2 poles of the Earth and passes through a given place. But there is no natural line for longitude that is equivalent to latitude's equator. Until international agreement made Greenwich, England, the prime meridian in 1884, maps reflected longitude based on a number of different reference points, such as London or Paris. Because Earth revolves through its 360 degrees in 24 hours, each hour represents a longitudinal difference of 15 degrees.
Thanks,
or
Bob.
roughly 60 nautical miles. Yeah, thanks, Bob. 69 statute miles. That is, of course, at the equator. If it is noon in New York City when it is 9 a.m. in Los Angeles, California, then the angular difference between the 2 cities must be 45 degrees. And a map would show a distance of about 3,100 miles, 69 times 45 between them. However, until the development of the marine chronometer, a ship's captain in the Pacific had no idea what time it was anywhere else unless he was adept at the lunar method. And The lunar method was a complicated technique requiring measuring the angle between the moon and another celestial object, like the sun or a star, and then consulting published tables of angles to learn the Greenwich England time of the observation. One would then have to find the current local time to make the comparison needed for determining longitude, and how to judge that accurately. In 1714, the British Parliament passed the Longitude Act, offering a prize of £20,000, and that was the anniversary of that was yesterday. That's worth several million today to anyone who could solve the longitude problem. John Harrison, 1693 to 1776, son of an English carpenter, began tackling the problem in the 1730s, creating a series of increasingly smaller, portable and more accurate timepieces called H1, H2, H3, H4 and H5. A viable marine chronometer had to be reliable and accurate. It had to resist corrosion from the salt air and remain unaffected by the fluctuating temperature and humidity conditions and the rocking movements of the ship at sea. In 1761, H4, which was about the size of a soup plate, surpassed the longitude accuracy requirements, showing a loss of only 5 seconds during a sea trial aboard a ship sailing from England to Jamaica. Parliament, however, wanted more testing and offered only partial payment to Harrison. In fact, the official reward was never paid to anyone, although Harrison did receive several additional amounts through 1773. Owing to his more than 40 years of work on chronometers, he is generally credited with solving the longitude problem. On his second and third voyages, Captain Cook was fortunate to use K1, a version of Harrison's H4 that was made by London watchmaker Larkin Kendall. With these two tools, sextant and chronometer, Cook would literally change the map of the world. On his first voyage, Cook determined longitude by the lunar method. Do we want to carry on, Terry?
Is there more?
There's more?
Oh, there's more. Oh, there is more.
Just as important as instruments, however, were the scientific methodologies that were employed on these nautical expeditions. Central to the scientific revolution already underway by the 17th century was the Royal Society of London for the Improvement of Natural Knowledge. The 1660s creation of 12 natural philosophers, including Robert Boyle, 1627 to 1691, discoverer of Boyle's law that showed the inverse relationship between the pressure and volume of a gas. John Wilkins, 1614 to 1672, founder of the metric system. And Sir Christopher Wren, 1632 1723, architect of St Paul's Cathedral. The members met weekly to view experiments and discuss science. The Society's motto, Mullis in verba, interpreted today as nothing in words, emphasised from the beginning its interest in equipment and proof, following the inductive methodology popularised by Sir Francis Bacon, 1561 to 1626, as a superior alternative to Aristotelian deductive reasoning. It is the oldest such society still in existence. For English seamen bound for far voyages, the Royal Society took an active role in developing guidelines for exploration. These were more widely distributed in its publication, Philosophical Transactions, giving some account of the present undertakings, studies and labours of the ingenious in many considerable parts of the world, which began in 1665. The Society asked Lawrence Rooke, 1622 to 1662, a mathematician and philosopher and one of its founding members, to think upon and set down some directions for seamen going into the East and West Indies, to aid their observations of natural phenomena. These would be recorded in journals and copies delivered to the Society and the Admiralty upon the sailor's return. Rooke completed his task but died before the Society's journal was born. His directions for seamen bound for far voyages, however, appeared in its 8th issue, January of 1666. In hindsight, Rooke's ideas seem fairly routine and commonsensical. Who wouldn't do that sort of thing? But after all, he was a mathematician, not a mariner. Yet until then, there had been no standard approach. Even if he had set the bar fairly low, the fundamental scientific process had begun. Here are his suggestions or rules for useful nautical exploration. In his own words, his italics. To observe the declination of the compass, or its variation from the meridian of the place, frequently making withal the latitude and longitude of the place wherever such observation is made, as exactly as may be, and setting down the method by which they made them. To carry dipping needles with them and observe the inclination of the needle in a like manner. These needles measure the magnetic dip or angle made by a compass needle with the horizon at any point on Earth's surface. The dip is downward or positive in the northern hemisphere, upward or negative in the southern. To remark carefully the ebbings and flowings of the seas in as many places as they can, together with all the accidents, ordinary and extraordinary, of the tides.
Where's that other bit you're reading when you were reading it the one before?
Oh, well, I saw the 2 little red stars, so I went down and read the bit that went with the red stars.
Oh, it's written down further. Okay.
Yeah. Well, I figured people would like to know what they actually were before I carried on.
Yeah. Okay.
Well, we did the tides, didn't we? Yes. To make plots and drafts of prospect of coasts, promontories, islands, and ports, marking the bearings and distances as near they can. To sound and mark the depths of coasts and ports and such other places near the shore as they shall think fit. To take notice of the nature of the ground at the bottom of the sea in all soundings, whether it be clay, sand, rock, etc. To keep a register of all changes of wind and weather at all hours, by night and by day, showing the point the wind blows from, whether strong or weak. To observe and record all extraordinary meteors, lightnings, thunders, ignes fatui, comets, etc., marking still the places and times of their appearing, continuance, etc. To carry with them good scales and glass vials of a pint or so, with very narrow mouths, which are to be filled with sea water in different degrees of latitude, as often as they please, and the weight of the vial full of water taken exactly at every time, and recorded, marking withal the degree of latitude and the day of the month, and that as well as the water near the top as at a greater depth.
Wow.
Latitude, longitude, currents, winds, weather, bearings, soundings. These are all basic data elements of any good ship's logbook, even today. By asking seamen to record them and share the information with others on the return of a voyage, Rooke was advocating a greater openness in seagoing exploration. And of course, they kind of knew what was on the seafloor as a whether it was sand or whatever, because the weight that they dropped would have a clay bit on the bottom, would have like a sticky clay on the bottom, so that when it hit the bottom, excuse me, it would actually pick some of whatever was on the bottom up, and they could bring it up and look at it.
Yes, clever that.
I think there's a lot more. There's a lot more to read here.
The equivalent of blue tack.
Yes.
The day's equivalent of blue tack.
Going by the time,
what
we
time?
might have to make a part 2 of this because there's still all that to read yet.
Oh yes, there's a fair bit, isn't there?
Yeah. And it's all relevant by the look of it. Just had to remember where we were.
Yeah. Well, the Royal Society is, I thought a certain Mr. Newton was involved in that as well.
Yes, I think he was.
I think we'll make a part 2. I think we'll get another part 2 out of this. Either be next Wednesday or next Saturday. Because we've got a lot more a lot as simple as what I thought it'd be, this topic, so it's going to take a little bit to get through. Well, thanks for that, Alan. Farmer.
No worries.
That's all right.
So we've gone out on the ship, we're taking samples and readings, and so far. But how do we know our way around? Well, we'll get to that.
Yeah.
Not like the old days where they used to just follow the coastlines. oh, I can't see the land. I better turn left and head back towards the...
Yep.
Don't know where we'll end up. Newton was president of the Royal Society at one time, Clive said.
He was indeed. Yes.
Is that Isaac? You're talking about Isaac?
Yes, Isaac Newton.
Yeah. Yeah, I was fairly sure he was. Actually, thinking about it, I think it was founded a bit before he became as prominent as he was.
How on earth is Paul able to see what he's doing with his back towards the...
Yeah, I'm driving the tractor backwards.
How come you're not running many of them over?
Occasionally, one does get run over,
Oh.
but there's a skirt. There's a skirt around the bottom of the tractor. So
okay.
There's a skirt that protects the front and the sides of the tractor, so they run around, but they don't get under the wheels. It's only if one happens to fall over and can't get up in time, and the tractor goes and it goes under the skirt and under the wheel, and that's not pretty.
So duck pizza.
Well, yeah, it's a sound that's kind of like this. You know, one of those party poppers where you have the streamers, fly out the top.
Yeah, pop.
Yeah, it's kind of like that.
It goes pop. The duck goes pop, not quack.
Yeah. We try not to do that, though. That's not one of our aims. Yeah. No. Around about, it's when they're sort of like teenagers, when they're around about or 8-9 weeks old, they get stupid, and the only thing on their mind is food.
Yeah.
I want to go and make a cuppa, so to do that, I'll keep all that in Discord in the stream topic stuff, so that's all put away. Okay, we'll need something else. Do you guys want to breeze through that F-16 pilot one, or because we don't have to do Lindsay, we can always skip Lindsay for that, replace Lindsay for the F-16 pilot video. It's a shame we couldn't, if I had time and an editing program that we could have edited out all the other crap from the other guys that were in it, and just the F-16 pilots conversation. That would reduce the time period of the video.
Trouble is that he's talking. I'm trying to think I'm trying to think of the correct word to use. He seems to be talking, whatever that word is, a lot.
Bullshit.
That might be the one.
Okay.
Or as you Englishmen say, bollocks.
Yeah, because I don't know if Globebusters are going to say anything if I play their video or not. That would be the...
Everybody's saying we can't skip Lindsay. That's blasphemy.
Ah.
And so if we edit it, yeah, we can't... I don't want to play that.
But it would be really difficult because it is actually it's more of a conversation, and for a lot of it he's talking anyway, and they're just prompting him along.
So really it needs a debunking video made about him, not so much just listening to him.
You could play the little 12-second clip I took out of it and posted.
Yeah, that one we could look at, but we could look at that after we've looked at a Lindsay.
Okay.
Because that's one thing that anybody who's done any amount of flying wouldn't say, even by. It's a lot of degrees, isn't it?
I'll just check to see what Lindsay's
I
done.
was listening to him on 1.5 speed, and actually didn't sound speeded up.
Well, this is your Lindsay videos. So the flat Earth creation model explained there. So he's got that one, and that one. I know they seem to follow on because he doesn't change much what's written on the board. So I think that one might be better to go to part 2 because we've seen that one. I think that one's... I don't know why he titles them like this. So we'll skip that one. Oh, it's only 10 minutes, 18 minutes, 26 minutes. He's all over the place. And 18 minutes at playback speed 1.25. Hey, I can't see anything on the board that's changed, so it hasn't rubbed nothing off. And then I'll get the one.
Video 2, the other one just ran out, talking about creation, the flat Earth model. Check out the first video. We were just talking about the solar eclipses, and the Egyptians have laid it out for us. The 3 pyramids in Cairo, Khufu, Khafre, and Mercury. Mercury representing Rahu, the black sun, because Mercury has to be aligned for that to neutralize the sun. For the moon to neutralize the sun, Mercury has to be involved. It's all chemical reactions. And you've got to realize Rahu, Ra's God, sun. Rahu, meaning the third entity, the other representative. And Ketu is the time, represents the time. So it's all about the time it happens. Because all religion, all this stuff, mythological stuff, all based on cosmology, the movement, and it's associated with man's brain, because man's brain is connected to the whole thing. And it's about enlightenment. This is how the kings are born. What the whole system's about. It's a divine period. This is what this is all about. The obelisk, the zodiac. It was all about when it was going to happen. These are all the ceremonies, all regarding the human brain and what's going to happen, when. It's all foreseen in the stars. The solar eclipse is the foretelling that Christ will be born. at a certain time. The solar eclipse at a certain time. That was the September, August. It's a man, Jesus, whoever will be born, a man child will be born, reborn, coming in September. That's what the whole system is all about. This is why they want you to bury all religions. The elites at the top, the Freemasons, and that they know, they understand all this. They don't want you to know about it though. You've got to get this out there, everybody. Try and get them to understand it's all about frequencies and celestial movements in the realm we're in. It's all connected with the human brain, and it's all about waking up the human brain. Otherwise you stay a dozy doe. Slave. This was all about being a slave. See the Anunnaki story? It's a riddle. It's not literal. Slaves. We are slaves to these elites. We run the whole system. We're letting them get away with it. Go get your jab, everybody. Yeah, really cool. What's this? The eye opener. Oh, that was the other day I mentioned. So, in the beginning, Exodus describes the whole creation story. How, Earth found that this was maybe like a bubble or something, but it found its resonating frequency. All of a sudden went bang, because prior to that, it was all chaos. Primordial waters. This was down. It was all down. There's nothing. Black.
Stop a second.
Waters.
Hang on.
Nothing. There's nothing. But
is
a frequency.
The bang going to start
that's
the
whole story.
resonating frequency or what? Sorry, I was trying to get you this. He said, "Bang!" The resonating frequency. Well, does the impulse start the resonating frequency, or is it? Because and what is the resonating frequency? And what is resonating, and what is what is it that's resonating? Can anybody tell us?
It's the frequencies, Alan. The frequencies.
Okay, but
yeah, the frequencies of what? I know.
Yeah, and what wavelengths do they have, and how fast are they going?
I heard him say you have a movement, and then you'll get a frequency.
Yeah, well, he clapped his hands, and I mean that's an impulse, but that doesn't give you impulses. Don't well, impulses have infinite have all the frequencies together infinitely, but assuming it's a true impulse.
I usually just flush my movements. I don't usually worry about the frequency.
It depends on whether you get an impulse or not.
Oh, okay.
Based on this resonating frequencies. It found the right resonating frequency, bang, it came to life. Then the chaos became an organised system. It started flowing the electrons.
You can't have bang with a resonating frequency.
We know this on Earth with electricity and magnetic fields. Once you get the voltage, you've got the magnetic field. Once you've got the magnetic field, you've got the voltage.
No.
It's feeding itself.
You have to move the charge to get a magnetic field.
Yeah, that's exactly right. It's magnetic fields related to current, not voltage.
This is how Earth works. It feeds itself. You can't see the sun's 93 million miles away, because it has to be inside this closed system. And it circulates the whole magnetic field. So once the sun was created, bang, it created heat. So then it starts raising all this atmospheric moisture off the sea into the atmosphere, into this closed system.
He never mentions anything to do with, like he says, the sun's over there in this toroidal field area, and if we're on that horizontal line as the Earth, and we can see the sun, what's stopping the other people not seeing the sun that's on the other side of the Earth? He's never, those ones you'd have to go back through his videos and try to figure out if he's...
Because it's a projection. Hole on the back of the sun means its direction makes it. I think there's a black hole on the back of the sun that somehow creates the variable lampshade that's needed to make it reflect correctly off the dome.
Okay. Don't tell Lindsay that. He might not have thought of it in that sense.
Oh, I'm sure he hasn't. Might not be anything solid up here. It's just the magnetic field.
Almig says he's fondling the boobies as he drew. Yeah, as long as Professor Phil's not
Charging the bombs.
out in the side chat, he would have noticed that.
It's just the ground, the magnetic field. So, obviously, if all the moisture's coming up the sea's going to drop. So all the water's sitting up here. And in a lot of religious stories, when they're talking about the seas, you have to consider they're talking about sea up here. And there's another story of being flipped, upside down. You have a sea
Water?
here and a sea here.
How do you get water up there? Oh, well, the fish will fall on my head.
Right.
This is all water.
Yeah, black hole sun.
Moisture.
No singing,
So
Dora.
you can imagine going up there as well, so you've got and then the sea levels dropping and then creating land. And then you get the whole Noah story. And then you've got to realise the Noah story is about creation. It's a story and it's connected at the same time to man's awakening. He found his resonating frequency because he's connected with the earth. His brain, earth is a brain. You've got the human brain and the earth. Whatever happens on earth happens with the human brain. This is where you have to connect all living life on earth.
Whatever happens on Earth happens to your brain. Okay.
We're all connected. So what we do, what we screw up in our brains, we screw up what's around us. Nobody can fix this climate change if you don't all wake up and stop all the violence and all the crap. Makes me think of Japan. I mean, hell, they go through a lot, eh? But they're out there slaughtering whales and dolphins. They're doing some evil shit on the planet. As a culture, as a people, they're lovely people. But there's some evil shit going on when it comes to slaughtering dolphins and whales. And I think they've been punished. People think that's
Focus,
just
Lindsay.
crazy talk, but
Yeah.
we're all connected. You can't hide from it. When you
What's happening on land is happening in your brain. I think Lindsay's living in a tornado or something.
realise how it all works,
His own mental
you can't
vortex.
deny it. We're all connected. Read Pythagoras. He spells it out. Why you shouldn't eat animal, why you shouldn't kill the pain, because they do suffer, they suffer. And that suffering comes into you. You take that suffering on board. You'll never be at peace. And at the end of the day, you've got the scales, you'll be weighed. This is the other thing about life. You've got to realise everything here is connected with nature, right?
Space
So
Matt's
that-
complaining
so
out
you
in
get
the
human
peanut
body.
gallery.
So you've got a moon, you've got a sun. There's light here, and you have it just off centre to the black hole. So you've got to think of the human body. He's got his black hole, and he's got his sun.
Well,
light,
no, he's juggling.
life,
Invisible.
reproduction, just offset from their dung hole. There's a black hole, a white hole, black and white. This is the
There's a
scales
joke
of
there
life.
somewhere, Lindsay.
You can either go
Someone
through
will
the
come
white
up
light
with it. Should
or go through the
screenshot
dung
that.
hole. Hades. This can happen in your physical world when you get.
There's a joke there somewhere.
You'll go to the white light.
There is, there has to be.
Well, human bums, he's obviously juggling them.
Yeah.
You know what I think, Terry? I think one day we should do a dub over of one of Lindsay's videos.
Wouldn't it be funny? We've got to get all the hand movements to match up with what we say, though, obviously, yeah. You're terrible, Paul.
Too, so you either go into the white light, the sun, or
Dolphins'
you go
fault,
into
they
the black
shouldn't be so
hole,
tasty.
be munted, distributed,
Thanks, Laura.
and come out as some other totally different form. Well, actually, that's the main route out. Actually, these are the divine ones. You want to go through the light.
Complaining,
You know,
was
you're
I?
born then. You'll get choices. Through the black hole, you don't. That's how.
We're going to deal with Space Matt at the peanut gallery all the time when he
So-
won't mic up go into
Okay,
Discord
we've got the
so he can
atmospheric
defend
monsters that we
himself.
get- remember, everything in there is all reflected out here, and all those celestial bodies are all set up in here in the elements, in the firmament, because that's what the planets are. It's all frequency based. Separate layers of atmospheric moisture, waters above them. It's all frequencies, different layers of frequencies. So this is where you're going to get different planets. They'll be sitting in those, each have their own different layer.
What?
Background stars are different. They're up higher around here because they're out here. They're projected out here. All the central stuff is all located in our ecliptic plane. The ecliptic, isn't it? The ecliptic, yeah, up in there. it's like the ring of fire around the sun here. It's within that zone, your planet and the moon and the sun.
Ring of fire around the sun.
And realise this is what the moon's doing. It winds around, down and out. It's always at epigee, at full moon. Science,
Space comma.
with their silly model, trying to fool you that it could be anywhere. Perigee. Perigee is always down the bottom here, closer to Earth.
Oh, space. I thought he said
Supermoon's
space
like
comma.
slightly different. There's more to that. But perigee and the supermoon is always down here. As for size and all that, supermoons, it's to do with your gates. Where you are standing and where it's coming through your gates. See the gates? Or whether it's your gates are here or wherever. It depends on the time of the season as well as to where the sun is. How far up north, how far down south, out of there, it's perigee. But it's based on these gates. So when you see that, you can see a full moon here, and 1 month you'll see the full moon back here, because it's out here, it's in that gate, it's back there. So come
Space
through,
Mate said, I got
like
back
this
and
to
I'm in
you.
trouble again.
It just seems like it's further north, because you're seeing it out here, full moon.
We don't need a reason,
You
Space
see?
Mate.
Because the moon moves around too with its cycles as it goes in and out. It's going like this. So it's all about these gates here.
Are
where
the
you're seeing
gates
it in
toll
the gates.
booths?
So
I
you
don't know
can
if they're
see
toll
full
booths.
moon one time there. Full moon might be over there one time. But it's
I
all
don't
to
know,
do
we
with
might
where
have
you
missed
are,
the one
where
with
you're
the
seeing it.
gates.
It spirals out like this.
What's that saying? You shut the gate after the horse is bolted? I think somebody might have
Yeah.
did that
Yeah,
with Lindsay's
bolt.
brain.
Bolt with the stable, close the stable door after the horse is bolted.
Yeah. I think that happened with Lindsay's brain. Somebody forgot to shut the gate. Are you the gatekeeper? Yeah, I know where that came from, Wolfie.
Right out, and back in again. And each month it just moves that little bit more around. And it goes into the sun carries it for 2.2 days, and leaves it behind, and it'll come out, and that's slightly different, a little bit further west each time it comes out to do its cycle again. So what else can I say? So, creation. Pretty much it, isn't it? You'll
Look at your
You'll find
notes, Lindsay. That
all
direction
the
where to
legends, all the
go.
logical stories are connected. If you
What
can
have
get
you written
through,
on the board?
get past the riddles. You just don't read it word for word. You probably won't, unless you understand this model, my whole flat earth model, you won't get the riddles, you won't see them. But once you know the model, I can read all those stories and know exactly what they mean. It's
Yeah.
easy. It's only in regards to all this religious and creation stuff. I can't go and decode codes. But if it's any writings, original writings, I can read them. And I know, it doesn't take long, I realise it's fudged, it's not authentic. Like when I first got into this and started reading all that Gnostic, all that religious story, like the Nagamati, old Nagamati, there was always this dispute about Thomas, what was left out. And there's two I read of Thomas. There's something or other in the book of Thomas. I can't even remember now. But one of them is fake ass. And just off the top of my head, I'm thinking it was the other one they thought was the real one. But one of those books of Thomas is you need to throw out. I can't say which one right now. I realise the white light is the sun. It's in many places. It's always there. We cannot see the real one. We see nothing of the real stuff back in here. We only see the projections. But it's frequency based. It's already here. The sun is always out here. During the day, that is. At night, it's different. It's turned away. And its positions is related to the magnetic field it's in. It'll follow the magnetic field. So the sun is always out here. It's on the top here. It's at the top because you're seeing through all the layers to get to the white light. The layers of the spectrum, the white light. And everybody has their own image of the sun. And you're right. If you've got pupils, you're attuned to that frequency. You will see it in your horizon. Everybody sees their own sun in their own horizon. Although it's on the same one track, the daily track, but you'll see it within your arc of horizon. The sun is in many places, but only seen in one, meaning it's only your image. It's not a object. And just recently they were talking about sun flares. What a load of bullshit. How can a non-physical thing have sun flares? You can't see the original one, and these are all projections, and it's everywhere. Which one had the flares? How can it have a flare? It's just total rubbish, everybody. There could be a magnetic field variation, because it's the flowing of the magnetic field, and it might resonate with the sun, because the sun, it's all part of it. But there's no flares. Total bullshit. Some sort of maybe vibration, maybe something. But no, there's been billions and billions of dollars, your taxpayers' dollars, to build all these telescopes all around the world for nothing, basically. Just about nothing, basically. Just about.
They all said the same thing.
Be left by all the historians.
Except for you, Lindsay.
Historians. That the Indians knew it all way back before the English white man came along and fudged it all. So, but it's life. Work like a slave, keep the elites up there, being at rest. Well, that's all I've got to say, I think. Run a bit thin now. Cheers. Share it.
Oh.
Get on these flat earth sites. There's plenty of other information, but
What?
not on hand.
Hasn't
We can't
turned the
bring
camera
around
off yet. What's he do? Who's he talking to? I missed half what he said. I was too busy typing in the peanut gallery.
Yeah. You really need to improve your thinking.
Multitasking.
No, grammar.
Oh,
Who?
what has grandma got to do with it?
Although, of course, I know you put it in there on purpose, Terry.
Where? What? What did I do now, Alan?
You put a space comma in there.
Where did I put where did I manage to fit me
At
space?
M to M.
Oh,
If it
yes.
isn't your fault, space comma, you need an alibi. In fact, I think it's a space comma space.
No, I'll just bagging space mat out.
Yeah.
Now, I have to download that video that Blue did. Is there any other easier way we could do this to save time? I could put it in here, I suppose. In videos.
And there's a little download tab, and you just tap it, and it'll
Yeah.
download it for you.
Yeah, I can't play it. I've got to.
Oh, hang on, I'll grab it, and then I can play it for you. How's that?
Well,
Although it'll play
yeah, I'm doing the same thing.
It should play. I mean, I can put it in a.
Yeah, I'm just wondering if I can do it that way. I'll know next time. How would it work? If I played it. Where are we? Where'd it go?
I could always do this, Terry.
Yeah. Where'd it go?
Here
I'll
we
make sure
are.
I play the right one. Well, it's got to be. It can only be learnt how to do it while we're actually live, so. Which one it is now?
Well, that's really clever.
I know, I downloaded it, and I can't tell which video it is.
Now it's in the shit. Now it's in the shit. Right, I can't.
Just lost it. Try again.
It would seem sharing it has killed the program.
Okay.
VLC usually works really well, though, doesn't it?
Oh, no wonder. No wonder I couldn't find it. It went to the wrong place. Now I've got it. Now I can open it up. And then I can do that. Drag it over to here.
Trained fighter pilots, right? And you would, in training.
Oh, pause it. Share. Oh, sorry.
Oh.
I wasn't quick enough to mute. I wasn't.
No.
It was one of those ones that happened so quick. Right, here we go. We should be able to hear it.
Trained fighter pilots, right? And you would, in training, it's always, you know, if a surface air missile comes up, or simulator, or whatever, you're very direct on the radio, like, you know, Cujo 1's defending Sam right 2 o'clock bearing 045, you know.
Oh, that's the bit to do with the two. Hey?
Trained fighter pilots, right? And you would, in training, it's always, you know, if a surface air missile comes up, or simulator, or whatever, you're very direct on the radio, like, you know, Cujo 1's defending Sam right 2 o'clock bearing 045, you know.
So what was wrong with that? 20 something 5.
2045. That's not a bearing.
How many degrees in a circle, Terry?
360.
Yes, exactly. So how could something be off to the right at 2 o'clock and have a bearing of 2045?
Okay.
It wouldn't even. Something at 2 o'clock wouldn't even have a bearing of 204.
No.
Or 045.
Actually, it would be 045 ish. 2 o'clock.
No.
Oh. half past one's technically 45 degrees, isn't it?
Yeah.
But at least 045 is closer to 2 o'clock than anything else.
Yeah, it's within the Flerf's margin of error, I suppose.
And he's been around, from what I picked up on, since the days when first Globebusters and all the rest of them were first out there on the YouTubes. So this would have been before debunking videos probably come along, before people actually started to see these other videos and start putting up and setting up their own channels to debunk these people. So he's gone down the rabbit hole back then which is more or less indoctrinated him into his thinking what it is now. If that makes sense.
Well, I don't know. He just sort of...
Because he hasn't heard the other side of it. He's only heard their side. Because that's what he said. He said it used to be like gospel to him to be watching all their videos back in the day. And that's what he thrived on. That's what he used to watch all the time.
Yeah. Yeah. I mean, a bit later on, I was listening to a section and he was blabbing on about the radar in the aircraft. And he doesn't seem to actually know very much about what the radar does and how it does it from a technical point of view. Now, I'm not saying that that's completely unexpected, because he only has to operate it. He doesn't have to know how it works, but he seems to not know enough about it to even be close with describing it.
But isn't that a way with a lot of people, that they've learnt something, not even realising what they've learnt, like just like parrot reading, so to speak, where you just learn something, you do it, you're just like a robot in doing it, you function by what you've learnt, but you haven't learnt the ins and outs of why and how and all that sort of stuff about something. If that makes sense to anyone.
Yeah. That's why you practice doing things over and over and over again.
It's like some race car drivers. They can race the car perfect, or the motorbike or whatever. But you ask them how the internal workings of the engine or anything technical about the vehicle, they wouldn't know.
Oh yeah, I had a friend who used to race motorbikes. He wasn't too bad at it, but he had absolutely no technical knowledge whatsoever, which made it difficult, because he'd come back in and he'd want us to tweak the suspension, but you'd ask him, well, what's wrong? And he couldn't really tell us. He could sort of give us a vague description, but it's like, well, what do you want? Do you want more damping? Do you want more rebound? Do you want more preload?
I just want to go faster.
Yeah, and you think, okay, hang on a minute. I mean, I used to keep a notepad so we could sort of, keep a note of what settings we changed it to. We go, okay, give him a couple more clicks rebound on the front and blah blah blah. Go out and try that. And he'd either come back and say, yes, that's helped, or no, that hasn't. You think, okay, it's not that. But he had no technical aptitude at all. He was racing this oh God, what was it? It was a little Honda VFR 400. Now that thing revved to something like, I don't know, 15,000 RPM, and it had a rev limiter. And he was out on the track and had a problem with it. And he thought, oh, that's okay. He was going flat out already. And he said, I just dropped a couple of gears and thought, it's got a rev limiter, it's fine. So one very expensive complete engine rebuild later. I'm sorry, there's this thing called mechanical inertia, because it was electronically limited. But I'm sorry, if you're already doing 15,000 RPM and you drop it 2 gears, the engine's not going to go, no, that's fine. You're fine. I'm already. It's just going to go. That's exactly what it bloody did.
Because oh dear, now the engine needs to be doing about 25,000 RPM to keep up with the back wheel.
Exactly. Yes. And the engine just said, no, that's it. I quit. Game over.
Yeah. So sorry, boy, but you're not having that much engine braking.
But this is also the same chap. When he first started out, there was a class out here called early stocks. And the rules were that the motorbike had to be air-cooled and twin shock. So you didn't have modern hyper-fast motorbikes. These tended to be old. So he had an old Yamaha RD250. It's now called Twin Shocks. And he blew it up out on the track. So, everybody comes back except your guy, and he comes back on the back of a pickup. So we have a look. He says, what happened? He says, well, I don't know. I think I blew it up. Well, the hole in the crankcase was the giveaway. And then we took one of the exhausts off, tipped it up, and the piston and most of the conrod dropped out.
Oh.
And he said, can you fix it?
Can you fix it?
Have you got a spare engine? No. Then your riding for the day is done.
Yeah, that's it.
That sounds nearly as bad as the other year when my son-in-law stalled the petrol lawnmower and the piston went through the engine.
Yep. I mean, he'd literally there was a hole in the crankcase where one conrod had punched through, and I think that exhaust had a lot of piston in it as well. But we said take an exhaust pipe off in its entirety and just tip it up, and it all come clattering out. Can you fix it? Yeah, hang on a minute. Izzy Wizzy, let's get busy.
So the blade plate on the lawnmower stopped, but the rest of the motor wanted to keep going, Alan.
Well, apparently Nathan managed to make the piston exit the engine.
Yeah.
And apparently it went through the hedge and into the field next door.
Yeah, First Death had the larger version, the RD400. This was an RD250. Might have been an E. Pretty much the last of the air-cooled RD250s. But I've never seen. I might have an old photo of it somewhere. I mean, there was just bits fell out everywhere.
At least it was a two-stroke, so less bits to break.
Yeah, I mean it's straightforward to fix, but it's like, have you got a spare engine? No. Oh well, that's it then. What, you can't fix it? Oh, look at it, man! You've just completely launched the engine. It's in thousands of fucking pieces. What do you expect? No, we can't fix it unless you've got a set of pedals, and you want to pedal it around the track. Oh dear, he hadn't got a clue. He could ride the bike, but that was it.
Matt made a good point out in the Discord about this bloke having his qualifications and that revealed, and he's over in America, and he does follow a lot of the YouTubes, so I wonder if it's any way you can get hold of him, because he said he follows a lot of people, so I haven't seen any link to who he is or whatever yet. I was looking around to see if we could try to chase him up somehow.
Yeah.
Track him down. Because we can't have people coming on shows like that saying stuff and then
That what he had to say about the aircraft radar system was the 10 minutes or so I listened to at 1.5 speed. He doesn't have a particularly firm grasp of what the radar has to do, even if it was on a flat surface, let alone it being on a sphere.
The other bit I picked up on was he said he flew at 35,000 feet without a suit, and he said he was with somebody else and he went up another 1,000 foot above that, and he said when he looked out at the horizon it was curved, but I can't remember what he was saying. He was saying something else about it, and I think the other guys might have jumped in on him. And
well, I mean, if you want, one of the problems of being in an aircraft is you need a nice wide field of view. And I'd say that if any aircraft's going to give you a nice wide field of view, it's going to be something like an F-16. So why wouldn't you expect to go up to sort of say 35,000 feet and possibly see some curvature, because you've got a lovely wide field of view. That's got a relatively unobstructed canopy.
If anybody give.
Oh, sorry.
Oh.
That was just the video. There was some stuff at the end of there were some tables that he put up, that he threw in. I don't know if you watched that bit at the end. in the
I need
video.
to go and watch that, to be honest. I haven't watched it.
They threw in these tables at the end. I was trying to figure it out what his point was. So there was his not the pilot, one of the guys on the panel.
Mm-hmm.
Throwing this in. And there was a couple there. There was that one, and there was that curvature comparison. It's like as if they were trying to make the plane stationary in reference to the curvature and the drop from the plane in the distance travelled. But the planes are level with the ground at all times, so I don't know how they were working out at
Terry, the problem is that they want the aircraft to fly in a straight line, which means that it would be climbing. But in fact, what the aircraft does, it flies basically at 90, essentially at 90 degrees to gravity all the time.
Yeah.
Yeah.
So it doesn't matter, because what makes the definition of altitude is the altitude above the geoid. So as you move over the geoid, your altitude stays constant, because you stay at a gravitational equipotential point, because the forces on the aircraft are balanced. Thrust and drag and gravity and lift all balance out to essentially keep you moving at whatever your airspeed is.
Mm.
Yeah, but in relation to what these graphs are that they were putting.
In fact, sorry, thrust and drag equal out to zero, don't they? Because you're not accelerating.
Yeah, but I'm talking about the graph that they put up on the screen, that I've got up on the screen now.
That graph is complete and utter bollocks. Because you don't start at ground level and travel out on the tangent of the point you were when you left the ground.
Have they got an altitude at all in this graph?
Yeah,
they've only got time travelled, distance travelled in miles, then they've got curvature something axis in feet and miles, then they've got the drop and the speed. What's their altitude?
I'm guessing the speed is how fast they're going. They're going to start at 0 feet. That's the problem. That's why I said it's complete bollocks.
Mm.
I'm sorry, but curvature is not measured in miles or feet.
No, it's measured in degrees. That's the whole thing of this 8 inches per mile squared crap. It's fine for the limited number of things there's a limited number of things that it's an acceptable use for, but there aren't very many of them.
No. Well, the more they're wrong, the more I learn. So obviously I'm going to learn a lot, because they're going to be wrong a lot.
Yeah.
That's how it works.
Because they've got to remember, the aircraft is at 10,000 plus meters, or 30,000 plus, 32,000 plus feet, and they're not even adding that to the calculation for the amount that it's got to curve. Because of course they're going around They're going around a curve that is big enough to bugger up the 8 inches per mile squared crap.
Parabola, yeah. Okay, what are we coming up? Oh, we're running a couple of minutes behind schedule, and somebody's still connected to the internet by the look of it. They haven't even.
Yeah, it's been good tonight.
Guess what happened to me last night?
What? You kicked your router out again?
Yeah, till this afternoon. I don't know what. Oh, they reckon I'll turn it back on and off and then back on again. Because the missus rang up and I didn't know she rang up. If I'd have known that, I would have got on the phone and went off at him.
That's always the first thing you do, isn't it? Turn it off and back on again.
Oh yeah.
Yeah, she rang him this morning when I didn't know because she must have been wanting to use the internet. I would have said, "No, I've had enough of this." Who do you complain to? Good question.
Yeah.
He wants some questions to you, Terry.
Is that a question?
Yeah, that's one.
I'll say yes. I got the first question right. Hey!
Okay.
Oh, that's one out of 4. Sorry. That's the only one I'll probably get right.
No, there's some good ones, easy ones that you'll even get, Terry.
Well, easier than usual.
Yeah. Terry, Dora reminded me. As well as the turning it off and on again, you need to whack it a few times. But the trick is knowing where to whack it.
Not like the old bloody valve TVs.
But you also need to swear at it as well.
Oh, okay. Yeah. Well, I wouldn't have thought of that.
And in my day in the Air Force, mechanics knew where to kick it, and technicians knew why to kick it.
Yeah, that's fair.
Fortunately, I was a technician.
Okay, you ready for some tough questions?
Oh. Yeah, and I'm in the right chat.
Right.
Nobody tagged me.
Here you go. Question number 1. Hammaker introduced a constant used for analysing these interactions that Lifshitz later adopted to account for the presence of a dielectric medium.
I thought that was
What interactions are we talking about?
Lifshitz.
Lifshitz.
Oh, Lifshitz. How do you lift your shit? I don't know.
Yeah, it's an unfortunate surname, isn't it?
It is in the English-speaking world, yes.
Yeah. No one knows yet. Okay. Many of these interactions can be derived by Rayleigh-Schrödinger perturbation theory, including one named for Keesom and a repulsive effect due to the Pauli exclusion principle.
I'm positive you've written down the Rayleigh-Schrödinger perturbation theory before in one of these clues.
What interactions are we looking at? It's not induction, Spooky Bed Hair. No. Okay, another clue. The volatility of white phosphorus compared to black phosphorus can be attributed to the weakness of these interactions. Not permittivity, which is, I assume, what you meant to say, Clive Wells. No. Not electrostatics.
Do let Wits it in here.
It's kind of related to electrostatics, but not really. The Leonard-Jones potential models these interactions, which cause non-zero second and higher virial coefficients in gases. Not the weak magnetic force, not turboencabulators, Dave Cannabis, no. Directivity, but we do have a correct answer out there. Okay. Identify these interactions, including ones named after van der Waals, which occur between chemical species not covalently bonded together. And we did have first death with a correct answer out there.
Oh.
Identifying one brand of these interactions. And they are the intermolecular forces.
Oh, right. Okay.
Yeah, so not covalent bonds, Clive. This is specifically not covalent bonding, right? Things like hydrogen bonding stuff. Okay, that was a hard question. Now for something a little bit easier, hey? A work by Cavalli, Sforza and Feldman argues that a type of this process can be used to explain changes in the Italian birth rate.
It still looks hard.
Yeah. What is this process? Something that can explain the changes in the Italian birth rate.
I thought that was just the words of the Pope.
A 2005 book by Richardson and Boyd is partly named for the cultural form of this process. Not contraception, Dora. No. Not condoms. Not sourcing. Okay. A work titled Unto Others attempts to explain altruistic behavior as a result of this process. Come on, it's getting easier now. The Italian sausage bistro.
Dave Cannabis, you're bad.
And we have a correct answer out in the peanuts. The selfish gene, Richard Dawkins argues that this process takes place at the level of the gene.
Oh, yeah.
Yes. Yeah. You know what it is now, don't you?
It's got to be that.
And it is, of course, known as biological process, the change in inheritable characteristics over time. It is evolution.
Aleister Crowley. What?
I like the animation.
Like the women keep evolving, but man just stops.
Yeah.
Yeah, that'll do. Yeah, we're all right there.
Yeah.
That's a clever one, that one.
Evolution was the correct answer. Okay, question 3. One of this player's greatest rivals saved 6 match points before finally losing to this player in a match that is, in terms of games, the longest Wimbledon ladies single final of all time. Who is the person we're talking about?
Tennis. Bugger.
I've lost the internal chat. So I don't know what you're typing.
That's okay. Nobody's typed anything.
Okay.
Not for a while.
Not for a while. No.
Okay. Well, you'll get this one. You should anyway. This player partnered with Ken Fletcher to become the only woman to win every mixed doubles Grand Slam in a single year. Not Billie Jean King, not Marie Curie. No.
Marie Curie?
I don't think Marie Curie.
I remember her being a
tennis.
famous tennis player.
No, I don't either.
Oh, God. Was it one
Not
of the
Boris
sisters?
Graf. Okay. They are the only player to have won 2 separate Grand Slam boxed sets in their career, in that they won each doubles and singles Grand Slam multiple times. Not Goolagong. No, Dave. Not Goolagong. Not Navratilova.
I know bugger all about tennis.
Can you see the chat again, Paul?
I can't, no.
That's a bugger.
Oh, we've put the
Well,
right
put it in the
answer.
outside
We've
chat.
put the right answer.
What I
in there.
can do is stop sharing, get the chat up and start sharing again. I'll just do that. All right.
Yeah.
No, it's
So
okay.
I'll
We
get
got the
chat
right.
up.
We got the
No,
right.
no,
answer.
it's not hard for me to do that.
You can take our word for it. We
Where
got
is
the right
it? There
answer.
it is. You've got the right answer, have you? All right. Now I'll start sharing that again.
Oh shit! We're gonna get found out now.
All right. Let's see. Not Serena Williams. No.
Is it the other one?
No, it's not.
Okay.
Not Heinrich Himmler. Not Virginia Wade. Okay, Martina Navratilova and John McEnroe argued that Yvonne Goolagong should become the namesake of a stadium named for this tennis player as a result of their homophobic views. So in other words, people said it should be named Yvonne Goolagong Stadium instead of what it was named after this player, because this player is particularly homophobic.
That's not his first name. What I wrote.
Nope.
Okay, it's not him then.
Blue.
Where's Blue? Oh, what?
Okay. Name this Australian tennis player the winner of the most Grand Slam singles titles in history. We have a correct answer out in the peanuts.
Yeah, that's who I was going to say.
Who were you going to say, Terry? You can say it out loud now.
Oh, Margaret Court.
It is. It's Margaret Court. Yeah.
My mum went to school with her, I think it was.
Yeah.
It was her.
She's a minister in Western Australia now, preaching religious stuff.
Never heard of her.
Yeah. Yeah. Probably known as one of the greatest tennis players ever. Yeah. Margaret Court. Okay, question 4. This phenomenon is described as a global herbivore in a 2005 paper by Bond and Keeley. What phenomenon are we talking about?
Herbivore.
The Aleppo pine releases its seeds in response to this phenomenon, and a feedback process involving this phenomenon is thought to have driven the expansion of C4 grasses. Not locusts. Not vegetarianism. Not Jeff Bezos.
Jeff Bezos.
Not termites, no. Flaking bark in eucalyptus species encourages this phenomenon, while sclerophyllous leaves permit growth after this phenomenon. Not rap music, Big Blue, no. But we do have a correct answer from Alan.
Oh, just as I was bloody typing it.
Yeah, and now Farmer's Boy as well, but nothing from the Peanuts yet. And finally, we do have from Dora the correct answer. Forest fires or wildfires, yeah. The crown form of this phenomenon moves through the canopy and is more destructive than its low-intensity surface form in regions adapted to this phenomenon. One method of agriculture involves slashing vegetation before applying this phenomenon. Name the phenomenon that has devastated forests in California and Australia. It is, of course, wildfires or fires.
Oh, bushfires in Australia.
Yeah.
So I got
Yeah, and one of the things I think is one of the biggest problems is, of course, that us humans don't like the fires, so we get all upset when places, we try and prevent it, and then it goes out of hand.
Yes.
Yeah.
Rather than just letting it occur naturally.
Well, that's
And
why
the
we do
miserable
we do back burning now, which sort of helps.
Yeah, and the miserable buggers went and banned stubble burning. Well, it did so much good on so many levels, but you had to be careful and you had to do it properly. And I think that was half the problem. I mean, you cultivated the fire break so that the fire couldn't spread to any other fields, but then you had to wait until the wind was blowing in the right direction and was going to remain blowing in that direction. Then all my dad had to do was sling a box of matches at me. It's like, yep, here we go.
Yeah, I mean, farming practices have changed over here too, though, Farmer's Boy. I mean, people still do it over here, although the really savvy farmers are tending not to do it now because they're realising that it adds a lot of resilience to the soil to leave it there, and they're using cropping methods where you don't need to get rid of the stubble from the previous year's crop.
Yeah.
But if you can leave it there and sort of incorporate it into the soil, that you have a much better moisture retention, and so your next crop's liable to survive a lot better. And as well as that, you're not putting a heap of CO2 into the atmosphere when you burn it.
There is that too, I guess, but
yeah,
it was a lot of fun.
Yeah.
I know a lot of the horse riders don't like the way the fields get ploughed up these days because they can't ride over the ploughed fields anymore.
Yeah.
Well, it should be on them.
Well, sometimes
okay. Question 5. Now, this is one you should get fairly quickly, guys.
Yeah.
A line in this song was borrowed from the 15th century song Riddles Wisely Expounded.
Oh, I know it well. What?
Yeah?
No.
Oh. Riddle me this.
Riddle me that.
Yeah.
Did Blue drop?
Guess he must have done.
Looks like it.
Okay, second clue. Bob Dylan drew heavily on this song and quoted a lyric from it in his own song, Girl from the North Country.
Yeah, I don't really do Bob Dylan.
Oh, Spooky's brought another friend.
Oh.
Somebody's birthday. Whose birthday is it?
Not Rule Britannia.
You can get a
I
spanner.
think Clive is thinking happy birthday, but
Charlotte Jenner can get a spanner for subbing because we don't like naked people out there.
Yeah. The best known recording of this song caused a rift by failing to credit Martin Carthy, whose original source may have been a Teesdale miner, and paired it with Canticle in the lead track of a 1966 album. It's not God Save the Queen, Dora. No.
Good old Sex Pistols.
Not Knocking on Heaven's Door. No. The impossible tasks mentioned in this song include making an object with no seam or needlework.
No, that's still not helping.
No? Oh, come on.
Probably going to wait for the last clue, I tell you.
Yeah, it looks like we're going to have to do it in the last clue.
Oh, you're only a baby.
Oh, he's the same age as me now.
51 years young.
Yeah.
Okay. Mentioning a cambric shirt and featuring the refrain, parsley, sage, rosemary and thyme. Name this traditional English ballad, which asks the listener about the title location in Yorkshire? Come on, you've got to know it now.
Scarborough. Yes. I think they're wrong.
Yes.
Yeah, it's that one.
Isn't that the Beatles?
Let's see if the Peanuts get it.
Yeah.
I got a couple of paid holidays in Scarborough. Thanks to doing some training courses at a place called Staxton Wold.
Elmix is just going through Iron Maiden tracks by the looks of it.
Try to cover all your bases.
Finally, we have one. Spooky bit here with Scarborough Fair, not Strawberry Fair.
No, that's what I meant when I talked. Hang on a minute, it's not that. It's bloody Scarborough Fair, isn't it?
Yeah. Yeah.
One of my least favourite of their songs, I have to admit.
Yeah. Okay, question 6. In a 1981 paper by Caldera and Leggett discusses the impact of damping on this phenomenon in macroscopic systems. I would be very impressed if anyone got this from that clue.
Well, Blue came back.
Oh, good man.
Ding dong.
Okay, the time for this process limits to a finite constant in apparent violation of relativity in the Hartmann effect. Come on, Clive, this one's up your alley.
I
want it to be up my alley. Hey, phrasing, sorry.
Cooper pairs exhibit this phenomenon in the Josephson effect. Come on, Alan. You might know a little bit about this too. Not bridge stability, no. Not an extinction event by an asteroid, no. The rate of this phenomenon is governed by the Gamow factor.
Yeah, whatever.
Not quantum reproduction, but you've got one of those words right, Sir Little Wolf.
Fleetwood Mac.
Not Fleetwood Mac.
Well, that's a quantum leap from Iron Maiden, yeah.
Not superconductivity, no.
There you go. That one?
That is correct, Alan.
Well done.
Yes.
Told you
This phenomenon is represented by a shift from a sinusoidal to a decaying exponential solution for the Schrödinger equation. Not back induction.
What's Death trying to write?
Quantum leaping. You're close, Dora knew. Not quantum leaping. It's the opposite of leaping. And Dora has it right this time with quantum tunneling. Yes.
Yeah, quantum.
Name this phenomenon. Yeah. In which a particle passes through a classically impossible barrier. It is quantum tunneling.
Quantum Leap, that was a good TV show.
Oh,
it was, yeah. I enjoyed that.
Yeah.
Quantum tunneling was the correct answer there. Question 7.
You can give up now, Wolf.
This country intervened in one war and won the Battle of the Sound. Come on, I'm after a first clue answer here.
Battle of the Sound.
A country. Out of all the countries, to narrow it down to one.
Not Belgium. No.
Elmix is on a roll. I'm doing so well, all wrong so far.
During one period, this country was led by its Grand Pensionary, and this country's unknowingly agreed to exclude one person from its leadership in the act of seclusion. not the Swiss, not the UK, not the Seppos. I won't accept that answer, Fred Bailey, but you're close. That would be correct. I'm trying to see the goddamn internal chat so small. Farmer's boy, yeah.
Thank you.
There you go, farmers. This time we're swapped round.
Yep, that's fair.
This country fought 3 wars with another country after the passage of the Navigation Acts. Finally, we have Spooky Bed here with the correct terminology for the country, the Netherlands. Yes.
Yeah, it's not Holland.
Holland isn't accepted. No.
Oh, look, it's Druss.
No, hang on.
I thought he
He's
was
like
here
that.
already. He's on the panel.
Oh no.
He's already.
Just putting the answer in the wrong place.
Yeah.
What are you doing out there naked, Druss?
Yeah, so the correct answer was the Netherlands. After being humiliated by Holmes' bonfire, this country's navy attacked the Chatham dockyards in the raid on the Medway.
Yeah.
Yeah.
I better check
The
to see
DeWitt
if-
brothers were lynched during its disaster year. Earlier, the Treaty of Munster guaranteed the independence of this country's united provinces from Spain at the end of the 80 Years' War. Name this home country of William of Orange. It was the Netherlands.
Druss says, but the Battle of the Sound was in 1628 between Denmark and Sweden.
Ah.
I wonder if Druss can figure out. Oh shit! He figured it out. He figured out. He figured out where we were and everything now.
The other farmer's boy.
Oh no! This is going to get confusing for some people.
Yeah.
No, it's not. We don't sound anything like each other.
I know you don't, but some
No,
people.
you don't.
Yeah, some people think you do.
Okay, question 8. In the Boussinesq approximation, fractional differences in this quantity multiply the gravitational acceleration to give the reduced gravitational acceleration.
Oh. This sounds like I should
What quantity is it that we're after? Well, this is something you not from this first clue, but it is something that you are familiar with.
Right. Okay.
For 2 fluids, the difference of this quantity divided by the sum of this property is known as the Atwood number. The Rayleigh-Taylor instability occurs when a fluid with a higher value of this quantity lies above a fluid with a lower value. We have a correct answer in the internal chat.
Already?
Yes. From Alan
Yeah.
and Farmers, and also out in the Peanuts.
Are we just
Dora.
taking turns, Alan?
I think we're just taking turns.
Yeah, well done, guys. The speed of sound waves is proportional to the square root of pressure over this quantity. The specific gravity of a material is equal to its value of this quantity divided by the value of this quantity for water. Name this quantity, which equals mass per unit volume. It is density.
Oh, yes.
Destiny.
Mass density. Because there are other kinds of density, you know.
Yeah.
In their first appearance, this character is described as shaped in an unalterable mould, like Cellini's cast Perseus. Who is it we're talking about here? Which character?
No.
This is in there.
Not the man in the iron mask. No.
You're a little bit behind, Wolfie.
Okay. This character has a long white mark from their hairline down their face and under their clothes, the origin of which is never explained in the novel in which they appear.
Now that should help. Hopefully you can hear me now.
Yes.
Yeah, we
Can
can hear
he?
you now.
Yeah, we can hear you now.
It's not Sleeping Warrior. It's not Phantom of the Opera.
Oh,
It's not.
I wanted to say Paul Dark, but I think that's too specific.
No, it's not.
And if you're going to answer in our internal chat.
Not Peppy the Pew. No, not Werner von Braun either.
Werner von what?
But Pepe Le Pew does have a big white mark.
He does. He does have a big white stripe,
Yeah.
but it's not Pepe Le Pew. No. The Parsi Fadala prophesizes that this character can only be killed with hemp. Oh, you still don't know.
No.
D.H. Lawrence famously had little sympathy for this character, believing that the titular character of their novel should have torn off both his legs and a bit more besides. It's not LePew, no, not Druss.
Oh no, I was saying everyone
It's
tell
not
Druss.
Nathan Thompson.
I was saying
No.
everyone tell Druss where's his avatar.
He's not coming naked, has he?
I have.
Yes.
I forgot to put an avatar on, and the fact that I didn't come in with my real name, because I normally use Zoom for work,
Oh,
Oh,
yeah.
that's
means I
right.
have to remember to change it back before my next meeting. Otherwise, it's a little bit embarrassing.
It
Yeah.
would be. It
Yes.
would be.
It would be, yeah.
Yes, with your current name, yeah.
Okay,
People-
come on. This is coming down to the last clue. In one chapter, this character nails doubloon to a mast, stating that whoever finds the novel's title character will win it.
Moby Dick.
If you're going to answer in the internal chat, Druss, but
Sorry.
that's not the correct answer.
Oh God, nailing the doubloon to the mast.
You're in the
that
right
rings a
story.
bell.
You're in the right story, Druss, but not the right character. That is the correct answer.
Melville.
Yes.
And First Death got it out there. It is indeed Captain Ahab. Named the captain of the Pegwood and monomaniacal antagonist of Moby Dick. It is Captain Ahab. Yes.
Pequod.
Yeah.
Yes, the Pequod. Call me Ishmael.
Last question. Nancy Johnson in the US and Agnes Marshall in the UK patented early machines used in the making of this product. What is the product?
Could be anything.
Could be anything. Yeah.
Could be.
The Soviet industry of this product, which was sold by companies like Plomber and Lakamata, was renowned for its high quality. Not cotton.
I was just thinking that as well. I was just trying to.
That is the correct answer. Who got that one? Big Blue, yeah.
Yeah, that
Well
was
done.
just my.
Yeah. Yep. No, it's not tofu. It's not rope. It's not paper. A traditional Iranian version of this food product is made from rice noodles and is often served alongside another variety of this food called kulfi, which was also popular at the Mughal court and today is usually formed in a cylindrical mold and served on a stick. That should give it away.
Yeah.
Not computers, not hemp.
Not napalm.
While working as a chemist, Margaret Thatcher reportedly helped invent a variety of this product. Yes, M2M's got it right.
My uncle's brother-in-law used to hold the record for the world's fastest manufacturing of this product.
Oh. How fast?
Seconds.
Ah. Name this frozen dairy dessert sold in the UK by Mr. Whippy. It is, of course, ice cream. So how does he make it in seconds?
Liquid nitrogen.
Ah,
Okay.
that would do it.
That's
yeah.
what I was thinking.
Yeah, that would do it.
He
And what's
worked with Heston Blumenthal. He's a food chemist, basically.
Oh yes, yes.
And he's the guy that goes down to the Antarctic to go and do penguin surveys. Because he's actually mad about penguins, him and his wife.
Well, I suppose somebody's got to be.
He made a lot of money basically making stuff freeze fast, so now he's getting to spend it.
Yeah.
Yep, so the correct answer was ice cream.
Are those
There you
girls
go.
actually?
Here's your quiz for today.
Are those girls actually eating any of that ice cream?
I don't
Yeah.
think that was the point.
No.
Ah, okay.
Oh, thank you for that, Paul.
Yeah, thank you,
Yeah.
Paul.
Yeah, thanks,
That
Paul.
was a really good quiz.
They all are.
In that case, I have been remiss not attending more often.
Yeah.
I'll get one
That's
right.
okay.
I'll get one right
That's
one
okay.
day.
I've been sort of filling in for you, as 'twere.
Filling in.
Well, I might be following the exodus of multiple people from Gem server. So, yeah.
Oh, I wonder why.
Well, I did
Actually, not what you
hijack a few people from Gems, which I got told off about.
And your 8 notes for the musical quiz. Anyone who can identify this tune.
Oh,
Anyone know what that is?
Can you do it in a different key?
I think I recognise the tune, but I couldn't tell you what it actually is.
Ah.
Yeah, same here. I'm sure I've heard it before.
Everybody loves Marla.
No, Wally said slower. Wally likes
It's
it.
the theme-
Wally
It's
likes it
definitely the
slower.
theme music for something.
It is. It's the theme music for a lot of things, probably.
Yeah.
And I'm trying to think, and it's a particular film I'm thinking of, and I'm trying to remember what the bloody hell it is.
While they're trying to guess that,
It could be Shostakovich Opus number 12 in D
Nope.
minor,
Nope.
which was also known as the Dresden overture.
Nope.
Didn't
Or
sound-
Opus, sorry.
that didn't sound like Twinkle Twinkle Little Star. That's
I'm pretty sure it's not the Horst Vessel either.
Sound familiar?
Yeah,
Yeah.
but if you're playing that, that's bloody annoying.
Yes, he is.
as long as he's not
yes,
wearing, as long as he's not wearing his microphone, because it sounded better.
Is it Rachmaninoff? No, it's not. It sounds Russian, though. It sounds Eastern.
It's not.
Ooh,
You
then it
might
must
go
be-
with French.
Really?
Yes.
Damn it.
Yeah, it's really
I'm-
familiar. Like Dora says,
really,
it's really
I know
familiar.
it, yeah, but I'm
Yeah.
really shit on French composers.
Yeah, you know the music, but you don't actually know what it is or who it's by.
One of my exes was a violinist, and her speciality was on Eastern European composers, and especially those of the 19th and 20th century. So those I'm pretty good at. So Shostakovich, Rachmaninoff. you
Oh,
know.
look, Clive Wells has got it. Obviously, it's Thunderstruck by AC/DC.
Yeah. Right. It's not Finlandia, no.
Definitely not Thunderstrip.
No.
That's slightly more up tempo.
We've got a 4-minute 43 from Blue. What's Wally got? Did we see that one? That was yesterday. No, we couldn't have seen it. It was yesterday. From Wally.
So can you, Paul,
Overkill.
Can you give us a clue? Is it 20th century or 19th century? Because I'm guessing it's going to be one of the two by the sound of it.
Yeah, it's fairly early on.
Doesn't sound like an Amadeus or a...
No, it's an Eric Satie.
Ah, so that puts it pretty much in between the 19th and 20th century, because he's what, late 19th, around the same time as sort of Ravel. Or Debussy. I would put him in that period. Because I thought it was Debussy. That was when you said a French composer. That was the first one I went to, but it's not.
He's mostly known for these like chanting like melodies. There's another one that everybody knows. Yeah, which one, Spooky Bedhair? You've got a choice of three.
I'm going to have to give a challenge to Paul now. I'll play you one of my favourite composers. I don't want to do that.
Yeah, but you are supposed to be playing it live on the piano yourself.
Well, I can't because this is a violin piece.
Oh, grab your violin then.
Yeah. No, Spooky, it wasn't number 2. It was number 1.
Michael.
There you go. That should be short enough not to get you tripped up. Less than 5 seconds. Right, 19 minutes and then I've got to start cooking. I'm trying a new beef recipe, slow roast. And basically actually flash fry it in a really, really hot griddle and then foil wrap it, then put it in the oven. And do it at sort of gas mark 4 rather than gas mark 9, which is what I do most of my roast chicken stuff is, or roast beef stuff out.
Is Terry gone AWOL?
No, I'm still here. I'm just setting up a couple of videos.
Okay.
I thought we were naming that tune, or a tune. Wally did a Level Earth Observer video, but he linked the original video, because I think 42 was the one he was mirroring. So we just played the original video from Level Earth Observer, as long as there's no music or anything.
You mean from Mr. 42 even?
No, this one's from LEO, this video. Oh. This is the video that they were... Mr. 42 did a video, and I think Wally's just mirrored it. So if we just played the Level Earth Observers video version, if that's showing everything. Not quite. Okay, so it might be a bit different. Okay. Why is that one different? There's other bits added in on it. Might have to do the 42. Might have to do Wally's then. Do that. There we go. Stealing.
Good day, gentle people. It's your favorite Mr. 42. Welcome back to my channel. Today we're gonna have a word. Oh dear.
I hate music.
Say thanks to my first patron, Dan Suania, and I hope I didn't butcher your name.
Right, this was arrogantly sent to me as Globe evidence.
Let me guess. You're arrogantly gonna dismiss everything without coming up with any evidence.
I thought, oh my god, this happened. Has it? Have we finally got something? It turns out, well, let's have a look. Copyright, fair use and all that. This is sent as evidence that I live on a cannibal flying through a vacuum.
I know. What do they have to have music for? How does Wally get away with the music?
Adam,
Because he
and tell
chooses
us
music
what's wrong
that's
with it.
copyright free.
Yeah.
Well, that'd be copyright free then. That music that they're playing.
Yeah.
A classical music
Either
is
that
not
or he's
going to
paid
make
for the
this look...
privilege to use it.
Oh, okay.
Adam, less. Anyway, if you want the original, just turn off the sounds. There's no sound in space. It has just been added there to please the ear.
It's terrible.
Please, Adam, tell us why. Enlighten us.
You know, I don't mind a bit of classical music. Calms the old fire in the belly sometimes. But I'm at peace with it now. Oh dear. Whoever it was who sent me this, just sent me this. This is nonsense, mate. Come on.
Come on, Adam, I'm waiting. We are waiting. Give us the evidence already.
The state of it. Now this is cited as evidence. Wouldn't this be good? Instead of all these dodgy camera angles, idiots with GoPros just gimping it up outside the space station supposedly.
Idiots with GoPros? Adam, this is not your local halfpipe. Get a word.
Instead of all this panto, hairspray and nonsense.
I think Adam has lost all his hair. That's why he's so jealous about the hairspray.
It would have been really nice. Just once. Instead of throwing litter out into space and then at the same time complaining about the fucking litter problem in space, it would have been really nice. Maybe just once have a camera that's live streaming and just throw it into space facing the ISS.
Okay, you got it, mate. Obviously that has been sped up, otherwise it would be way too boring for you, Adam. I hope you enjoyed that.
And we get to see live streaming footage of a gigantic man-made space station circling a ball that's got 17,500 miles an hour.
You can watch it live, Adam, all for yourself. the next time a Crew Dragon capsule is about to dock.
Wobbling and oscillating. How amazing would it be to see that gigantic space station going round a gigantic lit up Earth as the camera slowly drifts off into space.
Oh, you mean undock? Funny that you mention it, because that actually happened on the same day that you released that video. Or should I say, release the video again? Because it's not new, is it?
To unveil the mysteries of the heliocentric pantomime stage to us all.
Hop up, off you go, watch it.
But no.
But yes, you just haven't looked for it. That's on you.
That would be amazing. That would be incredibly beautiful and scientific.
It really is beautiful and scientific, and it happens on a regular basis.
But no, we'll get this.
You get this and the live streams. What more do you want? Be a happy man.
Of it now. Cans of Coke on sticks.
A stick, Adam? A stick? That is actually a crane in space. I'm really surprised that you don't recognize a crane. Isn't that your field of expertise?
This is that fucking soda pop thing we looked at about 8 months ago. Now it's got two, I don't know, umbrellas, and it's stuck on the end of a straw.
Adam, you often say that these things look ridiculous. But what should it look like according to you? I mean, it's in space. It doesn't have to be aerodynamic. It must be functional. And talking about things that look ridiculous, here is a picture of Adam.
It's all nonsense anyway, but... what the... fucking little as well. And I'm at peace with it now. Absolutely ridiculous.
What is ridiculous, Adam, is that you seem to think that lightning is a few hundred kilometers or miles long. I will show you what it is. Watch this.
I must watch 2001: A Space Odyssey again.
You saw that, Adam? It is called a river.
They chucked in some lighting, I don't know if you saw that just now as well.
Adam, on the bottom of your source video it says the words time lapse. The flash that you saw was multiple frames. Put one and one together and you will understand that lightning is not even a possibility there.
So you've got like a reenactment of a soda pop can with two umbrellas stuck to it doing a dance to classical music, and that is to sell the lie of heliocentric space to me.
And just like I called in the beginning of the video, he dismisses everything without bringing up any evidence.
Nah, I'm not buying it. Fucking ridiculous. I'm at peace with it now.
Yeah, Adam was so angry he actually stopped the recording halfway through a sentence or a word even. So that's it for today, I guess. I hope you enjoyed the video. Please like and subscribe if you haven't done so already. In the description you will find links to my socials like Discord and Twitter. This has been Mr. 42 out. Don't panic.
And there was a video I saw the other day by Level Earth Observer. Are you guys familiar with his channel? No?
Heard of him.
No. Never heard of him.
I don't think so.
I never heard of him.
I love that he asked that question and there's just this long pause.
Yeah.
Who?
Who?
Oh, dear. That's the best bit of Brandon's stream the other night because that's right at the start. And then, no, I never heard of him. Oh dear.
Oh, I won't need that one then. What's Blue been up to? Quantum Eraser? Miscalculating again?
Miscalculating again.
Yeah, miscalculating.
Yeah.
Oh, I see a duck. Were we meant to count the ducks while you got them on the screen?
Yeah, good luck with that.
Yeah. 1, 2 lots. That's troll counting.
Well, if they all stayed still, you just count so many in a square metre, and then you times it by the amount of meterage that they cover, and that'll be your guesstimate.
But they don't. They run around the tractor like maniacs.
Yes, they don't stay still, do they?
Oh, okay.
Hello, everybody. Welcome to Blue Marble Science. Alarmingly ignorant, fecklessly arrogant. Ladies and gentlemen, let me present John, the Quantum Eraser. Warning, severe facial and monitor damage alert is in effect. Get out those oven mitts. Push the monitors back out of punching range. And let's light this dumpster fire and have some fun. Here's Johnny.
Baltard Bozo Biodual, 16 January 2021.
Hold on. I think I see it now. So
Okay.
Are you saying that there is a big difference between 0.1 and 0.0000001 as far as pressure differential?
I think we see it now, along with every fourth grade mathematics graduate that can fog a mirror. And yes, it's gonna be a colossal differential. You see, your 0.1 is 1 over 10 or 1/10, and your 0.0000001 is 1 over 10 million. What do we need to find the difference between them? You guessed it, the least common denominator, 10 million. So your 0.1 or 1 over 10 is converted to 1 million over 10 million minus 1 over 10 million, which gives us a whopping 999,999 units of pressure differential.
Hold on, clown show. Did you just try to define 1/10,000,000th of a millimeter of mercury as a unit of pressure? Where did you study science? On the Carhartt aisle at Tractor Supply?
Oh, son of a... That's gonna leave a mark. You and the other 58 ball-tard spinning space monkeys on the panel that didn't correct you immediately would fail fourth grade intro to fractions and decimal notation. You numpty dipshits. Here, you can take this with you.
You know, John, in the context Biodeal was talking about this, he was discussing the difference between a vacuum of 759.9 millimeters of mercury compared to a perfect vacuum of 760 millimeters of mercury. A very slight difference in pressure. Have a look at this little illustration. Sea level pressure is shown on the right side, 760 millimeters of mercury. We call that 760 torr. The top of Mount Everest is 253 millimeters of mercury. The pressure Biodeal was talking about would occur at about 210,000 feet altitude. You can't even see it on this scale. Let's blow it up a little bit. And when we do, 0 is the thin line at the top, 0.1 torr is the thin line on the bottom. The pressure differential is that little red line you see right there. It's 1/7,600th of 1 atmosphere. That pressure difference is so slight, I would not even be able to account for it when I'm setting the altimeter in an aircraft. So stop trying to mislead people with huge numbers like that, John. We're really talking about 1/10 of 1 millimeter of mercury. You know, maybe you ought to go back to school and learn this stuff. And while you're at it, take this with you.
How do you like me? How do you like me? How do you like me now?
Yeah, how do you like me now, you clown? Hey, thanks for watching. Hope you guys enjoyed it. And we'll catch you on the next one.
Yeah, says it all really, doesn't it?
I'm just wondering if they intentionally make mistakes like that just so people can, I don't know, just to perpetuate their narrative. I don't know.
No, I think
No.
is that stupid.
He's made math mistakes that are so stupid many times before, Terry.
Oh, okay. It's a common theme with him then. Okay, so it's not.
Yes.
Yeah, okay. Like subtracting a number from another number and ending up with a bigger number.
Yeah.
Hey? What?
Exactly.
That was a classic.
Yeah.
Clive saying Taurus is a silly unit. It is always odd that people quote PSI at sea level and Tor at the upper atmosphere. Well, that's all I've got for you in videos. Unless anyone knows of anything else. There's not been any debates that have been around. I know Fight the Flat Earth's done his usual.
Well, other than Bev coming in on Jose's yesterday and making out that he knows more about surveying than the Royal Ordnance here in the UK, that was something else.
Have you got a rough idea in the stream? I've got it here. If that was the last one Jose did, because I can't catch Jose because he has it too late at night here.
Yeah. No,
I did try to stay up one morning, but it was nearly bloody 6 o'clock in the morning.
He was talking about how the Ordnance Survey surveyed the UK, and I can't remember who. Somebody found a document from the Royal Ordnance themselves, and it has a number of myths. And myth number 2 was that level is horizontal. And there's a description there of why, level isn't horizontal because the Earth isn't flat, blah, blah, blah. And Bev took umbrage with that and said, oh, there's a number of interesting terms in there. I've tried to phone the Ordnance Survey to ask them about this. So he thinks he knows more about surveying than they do. Let me just see if I can find
quite a ways along, Terry. Let me have a look. Oh.
Okay, check the M-Tune with Brian Leakey explaining his model of flat Earth. Okay, I'll have a look. I'll grab that too. While you're looking for that.
Let's see.
Yeah, I'm just
start maybe around 2 hours and 20 minutes.
Right, you want 221. That's where Jose reads out the first couple of sentences. And then I think that's when Bev sort of makes his comment.
There's a document there.
That's it. This is the document from the Ordnance Survey.
Right.
So yeah, go to 221.
Don't you want the document?
It'll stay on the screen. There you go, because Jose's going to read it out. There you go. That'll do you.
The first sentence all the way to here. Of course, myth number 2, a horizontal plane is a level surface. Of course, it cannot be because the Earth is round. Any gravitationally level, of course, they're making noise now. Any gravitationally level surface, such as the surface of the wine in your glass or the surface of the sea average over time, must curve as the Earth curves, so it cannot be flat. That is, it cannot be a geometrical plane, unquote.
So saith the Ordnance Survey UK. So if you're going to quote Ordnance Survey UK, you have to adopt their entire
Interesting choice in a few words in there, though, right?
No, that's a cut and paste
It says cannot. Yeah, I know. I've read it, and I've tried to get in touch with them to have a word with them. Strangely enough, nobody wants to have a talk.
You think you know
I'll
better
get round to it.
Ordnance
I'll get
Survey.
round to it in time. But
That's
yeah,
why
there's a
they're
few
bringing
strange
somebody
words
up.
in there.
Wow.
And also in
Must.
Ordnance Survey UK, they describe the ellipsoid to which all their maps are made with their equatorial and polar radii and the flattening factors, so that you can get to their Mercator projection and the scales appropriate for the distances from the central meridian. Yeah, it's all right there on how they use the sphere when they map the UK.
Yeah. Before, hold on, guys. Bev, only fair for him to address that. But first, really quick, in between, Gently's channel with a £2 super chat. What's a horn angle, Bev?
Dunno.
Thank you, Gently's. Appreciate that. We go back to the screen.
Don't know. Do you want to tell us gently? Give it.
I don't know.
Maybe super chat some money in. Maybe £5 next time, eh? Jose? Cheers, gently.
Yeah, whatever. Well, I guess Hold On hit me up with something on PayPal. I'm gonna look it up. And it is, yes, big PayPal hit by Hold On. $40. Holy hell, Hold On. Thank you, brother. That helps a lot, man. That's almost my whole internet bill for this next month, man. And with a few PayPal earliers, we all said we got internet for one more month. The show must go on. Thank you, Hold On. And there's a comment, a note in it, and I read it. For fuck's sake, babe, it's Friday and supposed to be a fun day. No room for educational stuff today. Oh, wait, carry on. Please, sorry for the interruption. Don't you dare buy WD-40, Jose. Yo, right on. Hold on. Thank you very much for your support, brother. I really appreciate that, man. Hell yeah. I'll mute myself.
I would imagine there's a lot of people learning a lot of things today. No? You don't think so?
Well, we just learned that the UK Ordnance Survey is absolutely in the spherical trig, spherical latitude and longitude, Mercator projections, scale factors, or polar radii, equatorial radii, flattening factors, and the fact that a level surface, like a pond of water, is not a geometrical plane. Yeah, we did learn that, didn't we, Bev?
Brilliant. So you've got a hump or a drop or both. I mean, like have you ever heard of what we call the Kozlowski conundrum?
It's not a hump.
It's not a hump. It's just a drop then.
It's a curve.
Okay.
Because you're standing on a very large ball.
I just say I think I can prove a straight line.
Whippy fucking do.
No.
Yeah.
Yeah, the earth is still a ball. Do.
Well, you can, like I say, I'm not saying anything. I'm just saying that level is horizontal. It is a known observable fact,
and
isn't it?
We have our known observation of the LIGO's vacuum tubes, which are built as a tangent at a point and are straight and are not a constant elevation. Done.
Okay, Bev, if you build it, they will come. And Gently's channel came up and stepped up to the game with a £5 super chat. A horn angle, a horn angle is a non-rectilinear angle. Bev, only one straight line.
Okay.
Shout out to Gently's channel. Have you heard that before? I haven't.
Well, I would imagine like a rectilinear angle, like I said before, is between two straight lines. So that's measurable in between two straight lines. I just assume that a non-rectilinear is a non-measurable angle. You know, it's just a. It says it only one straight line. See, if there's only one straight line, then what's the angle? Where do you measure the angle? It's just ridiculous to assume it's measurable.
You're saying that the angle doesn't exist, period.
No, I'm just saying you can't measure it, can you? You need two straight lines in order to measure an angle.
If either the angle exists or it doesn't, which is it?
What is an angle?
Man, are you listening?
No, I'm asking you. Like, what you want to do? I'm defining an angle as being measured between two straight lines.
Yeah, a rectilinear angle. A non-rectilinear angle obviously is not the case. So, are you saying that non-rectilinear angles don't exist?
They wouldn't be measurable, is what I'm saying.
If they exist, then they're measurable. Do you agree with this?
They're not measurable. You need a rectilinear angle in order to measure it. It's crazy.
You're not answering. You're not actually engaging in the conversation that I'm having with you.
Yeah, you're answering a different question, Bev.
Well, I'm speaking purely geometrically here, and
I mean, did I say that you are avoiding to answer the question, Bev?
Yeah, it is. So, do non-rectilinear angles exist? Yes.
Is the rectilinear part of the angle, is that the line part of it?
Yeah.
Yeah, a rectilinear angle is between two straight lines, but you can have angles between a straight line and a curve.
Yeah, that's what I was thinking.
So that's a non-rectilinear angle. But Bev, I suspect, has never heard of non-rectilinear angles, but he thinks he's the bloody expert on geometry.
Yeah.
You know, and like I said a couple of times later on, he's so arrogant that he thinks he knows better than the Ordnance Survey. It's unbelievable. His arrogance is matched only by his ignorance.
That's Dunning-Kruger for you.
Yes, it's a perfect example of Dunning-Kruger.
Yep.
He's camped out at the peak of Mount.
The
summit of it's just words. I'm struggling to put it into words. I mean, the sheer bloody arrogance of this complete and utter idiot. You know, I've no doubt that he has actually tried to get in contact with the Ordnance Survey to tell them that they're wrong. You know, and he claims to have a GCSE in land surveying, something which I'm fairly certain, 99% certain, doesn't exist and has never existed, because you don't do surveying. GCSEs is what we sit now when you're 16 and want to leave school. And he claims to have one, which I've seen it, and the bits he'll show, and I'm not sure about that at all. But yeah, the arrogance of the man is unbelievable.
Bugger. I was trying to speak, but I hadn't realised I'd muted my bloody microphone. I'd not heard of a horn angle before, so it took me about 15 seconds to Google it.
Yes.
To find out defined as the angle formed between a circle and a straight line tangent to it, or more generally, the angle formed between two curves at a point where they are tangent to each other.
Yes, he's never heard of it before, but he's the one who likes to use obsolete and archaic terms to confuse people.
Yeah.
So.
Oh yeah, and of course he won't discuss radar with me because it's not a first order measurement,
as he keeps calling it. Yeah.
Not quite sure what that's meant to be either.
I can't remember how long it is into this now until he rage quits, because he did. He rage quit.
Oh, did he?
Which is always nice.
Because first order measurements wasn't something I could Google very easily.
Yes or no? And if not, well, how do you know? And if so,
as a word, he's just wrote it down. Gently's just said a horn angle is a non-rectilinear angle.
You saying words too. You know that, right? You're just saying words too.
Exactly.
So you're saying that rectilinear angles don't exist because they're words?
No, Gently has just wrote it down. Does Gently assume that they exist?
Hold on, man. I'm asking you. You're saying they're not measurable, but how do you know?
Because
Either they don't
you
exist or
need
they do.
2 straight lines in order to measure an angle.
What kind of angle?
Angle. A rectilinear angle is an angle between 2 straight lines. Do you want me to get you the definition of it?
You're saying that
Within mathematics.
Watch, pay attention. You're claiming that non-rectilinear angles don't exist.
No, you're asking me a stupid question.
No, it's a very on-point question that you're avoiding.
Are you talking geometrically?
So geometry.
One quick point.
So he's implying that geometry is straight lines. That's what he said. You're speaking geometrically. So for non-rectilinear lines, you're speaking geometrically.
He only ever talks about straight lines. That's all he seems to be interested in, and he thinks that's all of geometry, straight lines.
It's not, of course.
No, of course it's not. But that's all he ever talks about.
Which level is horizontal, you know.
Shout out to Flirspective in the chat. He say, thanks, Web. And there's an observable fact. I am $5 richer.
Get Ramsey in here.
With a $5 super chat by Dave Johnson, an observable fact is I am $5 richer. Thank you. Flirspective say, Ruhif destroyed you, babe, a few days ago, and is on your channel too. Damn.
Oh, you mean when Ruhif said he wanted to record me to get me to say something that I would never say anyway? Remember when we were talking about Go Fraud Me's, and I in particular was talking about a drone Go Fraud Me. Ruhif said that it was a fraud if you set out to do a GoFundMe.
We don't know what you're talking about. That's not interesting. That is not interesting. That has nothing to do with...
It's very interesting.
Babe, because listen to me.
Ranty says that I got destroyed by Ruhif. But
that is that is not interesting. That is something that is drama and personal related. We're talking here today about angles and all the stuff that's more interesting. You got to unmute yourself, babe. Oh, he left. Because I muted him so I can say something. He got butthurt and he dropped. Maybe it was a mistake and he dropped by mistake. So
did he come back?
No.
Oh, okay.
No, and you could hear, because he wouldn't stop talking, Jose muted him so that Jose could talk. And as soon as he got muted, that's it, gone.
Gone.
Yeah.
He wanted to talk about something else.
Of course he did. He wanted to change the subject because he knew he was losing the argument.
Isn't that
it's what they do?
It's what they do, yeah. It seems to be a popular tactic with flirters.
Yeah.
You get so far with them with the questions, and then they question back, and then they still can't answer, and then they'll change it to something else.
Yep.
Yeah. So we've got that one. And somebody said something about a McToon one. I don't know if I've got the right one.
Hello, I'm...
What? Where? I don't know which video it is. Who asked for it? Somebody out there in the Elmix, wasn't it? Have I got the right video, Elmix? I got crowdfunded anti-5G lawyers guaranteed to fail. That's not that one, is it? 'Cause that's the only one that was in Show Your Shit.
That's a reasonable video. That's a reasonable length video to watch because it's not a 2-hour live stream. But it's 5G. It's not flat Earth.
No, the one I found it was put it in any other vids Elmix did. The one that he's talking about. They went for 4 hours.
The coordinate system that I would.
Whoa. Okay, so I've got no idea whereabouts to play it.
Brain leak, PhD Tony and Planet Walk.
Yes,
That was Tuesday night.
PHT Tony's there. Where's Brain Leak?
Brain Leak was on the Brian Leakey. Brain Leak.
Brian Leakey.
Yeah, he was on there. I didn't watch it.
I caught the end of it because I woke up. I went to watch because it was supposed to be Ratoth or whatever it was.
That's right. Oh, yes, I did catch the end of that because I woke up and looked at my phone and thought, hang on, MC Toon's still going.
I woke up and it was still going because I put it on and got into bed and it was still going when I woke up.
Blimey.
In fact,
for
some reason, I thought that Toon was looking at a recording of Tony and Brain Leak because the conversation sounded so familiar.
Yes, as they
the stuff that he was telling him, I actually thought was recorded. I didn't realise it was live, all live.
Yeah, it was July 7th. So that was only Wednesday, so we didn't watch this on Wednesday.
It was, well, I say, yeah, it was. It started our Tuesday. It started like 3 o'clock Tuesday morning, 4 o'clock Tuesday morning.
Okay, so after my life.
And then finished about 9:30.
Okay. Whereabouts should I do it? Hour to 2 hours is pretty much the best derp of Brian. From 1 hour to 2 hours. Because I thought I could see him at the end of it here on screen.
This is the skill level of writing that he has.
This is 1 hour.
Right? Yeah, you still can't read it. Nobody should. I don't blame you for not reading it. I don't know why somebody winds up that terrible. Yeah. That's the guy claiming to be the somehow.
You sure you got the right timestamp,
incarnation
Elmix?
of both Egyptian gods Ra and Thoth. Somehow. The light of wisdom, as he calls himself. This poor soul, he needs Jeebus. He needs something. Maybe he could live in one of those places and it's a false hope. I have my sister gave me a sticker. Put on my phone.
I think you got the wrong part of the video, Elmix.
I never did. She called me like, hey, I got these present. What were you going to present? Something for
Yeah, it's a model that I mapped out, just a mathematical refraction model. I mean, it's kind of ad hoc. It's the same thing as the globe refraction. It just like with the 7/6R and the way they adjust that, it's nonlinear, and it hold on, is my microphone all right, or could it be better?
I think it sounds okay.
Do you want to share that in here as well, Terry?
Oh, sorry. I was trying to make sure I had the right.
Is that better or worse?
Sounds the same to me.
Hey, the peanuts are more important than you.
Okay, so the model,
Know your
the
place.
refraction model, that, like Rumpus and I'll say who's the guy? Anyway, I can't think of the guy's name who they used for refraction. The guy, that professor.
Andrew Young.
Yeah. Andrew Young. I think Rumpus mentioned something about talking to him and that's who told him that it wasn't mirage or anything. It wasn't looming. It was standard refraction. is why we see the horizon so far.
Yeah.
Like black swan. So that's that's a non-linear refraction model. So I just said, well, man, if they can do that, then I'm basically just going to make a flat Earth refraction model. And I just took the first thing I did is I looked at the distances in the severe
Why is
northern
playing a walk
hemisphere
upside down?
to the North Pole. And
This is from
man, they
down
were a
under.
little bit wildly
Yeah.
inconsistent, man. I advise anybody to check that out
What
to
do you
confirm
mean?
that.
What do you mean?
Well, let me give you. Okay, so if it's 69 degrees per mile, 69 miles per degree, then you would expect something at at latitude, let's say 20, you would expect it to be around 1,400 miles, right?
To the North Pole.
Right.
Okay.
And you just get some inconsistencies. Okay. All right. I'll just say, for the sake of speeding this up, maybe it's me, but if you want to check it out,
I think it's probably just you.
Okay. Well, I'll go with that for the sake of speeding this up.
Okay.
Because I don't have any evidence of that, just what I've seen. But anyway, so I just did the math and everything on the angles, and basically I come out with a model. Let me see. So I come out with a model based on the sun from the North Pole to the equator is 6,100 miles. Okay, and the height of Polaris I have gauged at 3,655 miles.
Okay.
The sun elevation I have about 100 miles less than that, and the moon about 100 miles less than that. Okay. And the way I did this refraction model is when you get to 60%, there is no refraction. When anything,
hold on, 60% of what?
60 degrees, I meant. Okay, thanks. When you get to 60 degrees of looking out.
That's Anchorage, Alaska.
No. Hold on. I kind of jumped the gun by saying that, but just follow me. Me, and you'll put it together in a second. So basically, it starts from 100%. Okay, at 1 degree, it's 100% of my refraction, which I'll tell you in a second. And then it goes to 99 at 2 degrees, 98 at 3, 97. And then when it starts getting higher, it drops a little faster. But by the time it gets to 60 degrees, so when you're looking out in the distance, by the time you're looking 60 degrees up in the sky, above the horizon, there's no refraction at all, or very little. Okay, so what it is, the refraction is it's light refracting upward at 6 inches per mile squared, and the percentage at 1 degree. In other words, basically everything we see off in the distance, even mountains like Canigou, is well under 1 degree. So any terrestrial observations we have are going to be within the one, maybe a smidge over 1 degree. So basically everything off on the horizon is going to be 100% refraction with 6 inches per mile squared, because 8 inches just didn't work. Okay, but it works with terrestrial observations.
I got no idea. I don't know how he gets
it. I have no idea what he's just literally making shit up.
Send you. I have it on paper. But anyway, I graphed this out. I put this on a graph.
How does his refraction? I want to know how his refraction works.
I was surprised when I seen it.
I'd like to see it written down.
And I charted it.
What he's saying. Or trying to say.
I was pleased when I seen it because
all right,
this kind of matches 8 inches per mile squared.
Let me go ahead, Planar Walk.
I just want to ask, what do you know about refraction? Like, what do you know about how refraction works?
I know that it's not as consistent as they like to say, I know that, okay, I think this, okay? If light is curving, you attribute looming to light refracting downwards, okay? Making something look higher.
Yeah.
Okay. Yeah. And you attribute that to a pressure gradient. Okay. But now I can show you demonstrations of a guy about 100 feet away, 2 inches off the warehouse floor, several of these, but a guy 2 inches off the warehouse floor with a camera just sitting there, just recording lights, which are also about 1 inch or 2 off the ground. And then he opens his garage door and lets cold air in. And all of a sudden, the lights disappear for a minute until the air equalizes out. Well, when the sun comes out, now the sun refraction is said to be more during the heat of the day. That's what George Nutsack would say. Or,
George
I don't talk shit about his house.
Yeah, you probably don't need to insult him.
Yeah. Man, I hope his dog wasn't in there, dude. I hope Con wasn't in there, man. Golly. I don't even want to know if he was, dude. I hate thinking about shit like that. But yeah, I'm all support to him, man. I'll call him George Numchuck tonight, man. But he knows I'm cool with him.
It's
Anyway,
George. Just so people know at home, George Natchik. He lives in northern Minnesota. Where I live in Minnesota.
How close are you to George?
He's on the very far north edge of Minnesota, and I'm in Minneapolis area, which is mostly towards the south. We're about an hour from, or 60 miles from the Iowa border.
Okay. You like the Twins and the Vikings?
Is that a sports ball reference?
Yeah. Okay. If you don't even know the reference, then the Twins and the Vikings.
Yeah.
Yeah, the Minnesota Twins and the Minnesota Vikings.
This is my sport. I like this.
Yeah, there you go. Okay, so anyway, and then plus Jesse Kozlowski, I've heard it across the board. Correct me if I'm wrong, but refraction
you're probably wrong.
in your model. Well, I got it from them, so it wouldn't surprise me. But I'm just going off what they said. So they say that they claim that refraction is greater in the evening and in the morning and during the night.
Yeah,
when the sun is out.
It peaks. Refraction peaks typically later in the evening, quite a bit after sunset.
Okay, so based on your model, then that's perfect. But my argument to that would be, okay, if it's based on a gradient, temperature, pressure, whatever, gradient you want to call it.
Hold on. It's based on measurements. So you know. Okay, go ahead.
Right, which match your model, right. It's not based on measurements, because if I go survey 5 miles down a beach and I close my loops, even double rods, I'm going to get no. Listen, you're going to tell me that I'm working my way around the globe. I'm going to say
refraction. The refraction, the quantity of refraction, is based on measurements.
I lost you for a second, man.
The quantity of refraction at different times of day is based on measurements, not on modeling.
Right.
Measurements.
No. It's 100% based on your model.
mctune.net/refraction has numerous studies of refraction measurements.
Right, but listen, if you're looking at something, okay, off in the distance, whether it be 100 yards, whether it be a mile, okay, if you can't base where, okay, the best way I could say it is if I take my instrument and I go survey 5 miles down the beach, okay, and I double rod, making sure I'm keeping the same angle, but you'll still say, I could go and close.
Have you done this?
Yes, no, I've went almost 2 miles. But I've talked to surveyors who do it every day.
Okay.
Planar surveying, state planar surveying. How do you think?
Not geodetic
do these
surveys.
surveys,
Okay.
man? Right, exactly. Not geodetic surveys. Geodetic surveyors do state lines and shit like that. They're not elevation. We do not make our maps based on geodetic surveys, except for mathematically.
Actually, they do.
Just so you know.
Yeah, go ahead.
Okay.
Go ahead.
Well, anyway. Well, if you take your instrument, the same thing will happen. They won't argue this, okay? But what they will say is that I'm curving, like every time I set up my device, my instrument, that I'm changing my angle, okay? I've got a couple arguments for that, but, for the sake of argument, okay, it's possible. But if it is not, then it's just, you're just basing the refraction model. I mean, you're basing the refraction on your model, whether it's true
refraction
or not.
on measurements.
On measurements on a globe, right.
Hold on, I do want to say, do you know how refraction, like all the different components
I'm trying to get to
how
my
refraction
point,
is
man.
calculated?
I'm trying to get to my point.
No.
I'm really trying to get to the point.
Will he ever get to his point?
Hold on, can I
No.
just ask you, do you know
go,
about
go.
Snell's law?
It's so frustrating
but
trying
that's
to
changing
listen.
mediums, bro. That's changing mediums, bro. I'm not trying to talk about Snell's law.
What?
You have Wait, Snell's law? Isn't that something to do with what happens at the
That's
horizon?
refraction.
Yeah. What? I'll go back.
Snell's law, the changing angles as you go through different mediums.
Oh, we're not talking about Snell's law, though, are we? No. What?
I hope you're talking about Snell's law if you're doing refraction.
Yeah, but this is Brian Leakey. Brian Leakey. Don't forget.
I know this is brain leak. That's what I mean. Sorry, Terry. I don't know. I might be just misunderstanding you because I'm getting tired now. But yeah.
Yeah, but Brian Leakey said we're not talking about Snell's law, though, to do with refraction.
Yeah.
Okay.
I'm sorry. That just broke me.
Yeah. I think it'd break anyone trying to listen to this guy.
I'm trying to get to the point, and I'm catching some friction here.
Hold on. Can I just ask you?
Yeah,
do you know
go
about Snell's law?
Yeah, but that's
You know about
changing
Snell's law?
mediums, bro. That's changing mediums, bro. I'm not trying to talk about Snell's law.
What refraction is Snell's law? You
still tend to.
You can't.
So you're trying to apply Snell's law to terrestrial refraction now?
Absolutely.
Is that what I'm hearing?
Yeah.
Okay, that's great. That's wonderful. Okay. Well, anyway, let me say my point, because you'll probably have a lot more contention for it when I get to it. Okay. So the point being is that the density, the air temperature and density or pressure are pretty much hand in hand, according to the gas laws, right? I mean, can you agree with me on that?
Air pressure and density are based on.
Can't use the gas laws for the atmosphere.
Temperature. I mean,
Hey, what's that, Blue?
It's really not appropriate to try to use gas laws for the atmosphere. You don't have a defined volume.
Yeah.
Say temperature and pressure are tied at
the
the hip,
ideal
right?
the ideal gas law. Yes. Yeah.
Okay, so PB equals NRT. Okay, so basically, as you go up, you here's my whole point. I'm just going to cut right to the chase. Okay, so my claim is when the sun's out in the heat of the day, no matter where you're at, it's heating up the ground. Okay, and so the surface, especially over water, with the sun beaming off of it, or should I say, especially like asphalt, but any ground's going to heat up when the sun is out, and so it's going to be hotter. Okay, it's going to, over the water, it's going to evaporate more water, and water vapor is way less dense than air. Okay, the water vapor. So that would refract.
Oh, you got that one right.
If you're looking out over the ocean or especially if you're looking 6,000 miles at a setting sun, you're going to have a pretty consistent refraction gradient.
What? You can see 6,000 miles with the setting sun.
And but it's based on water vapor and the sun being overhead. So I would say
you're ignoring temperature then.
What do you mean temperature?
Well, you're using water vapor and ignoring temperature.
Well, if you look up, according to Blue Marble Science, and what he read to us on Jose's is that temperature comes second, the pressure comes first. Okay, so in other words,
but you were talking, yeah. But pressure is consistent. Pressure is consistent at. Hold on. I have on screen right now measurements of the coefficient of refraction at different times of day.
Do you remember saying any of that, Blue?
I don't know what he's talking about. I think I did. I am probably responsible for convincing him finally that water vapor is less dense. True.
Okay.
I think he finally got the message that two O's is going to weigh more than an O and two H's. That's simple.
All right.
Do you see that?
Okay, flatten the ground and then draw your graph.
No. This is not over. This is not topography. This is time.
Yeah, well, don't get stuck in your model.
This is
Think about
time.
if it's concave, map it out concave, and then map it out flat.
This isn't a model, and this has nothing to do with the shape of the Earth. This is strictly
Are you sure about that? Because what you have is
hold
a
on.
curving.
I was in the middle of a
curving, bro.
I was in the middle of a sentence there.
I'm just trying to stop you, bro.
Yeah.
I'm trying to stop you because
I'm trying to not have you stop me,
bro.
I'm trying to not have you stop me.
All right, bro, go ahead.
I'm specifically telling you that these are measurements. This is not a model. This is measurements of the coefficient of refraction over time.
On a curved surface with a curved atmosphere, correct?
This is measurements. It doesn't take into account.
I just told you about measurements, man. You can ignore it, bro, or you can acknowledge it.
It has nothing to do with anything regarding shape of the Earth or topography. This is strictly about the coefficient of refraction. That's all you're looking at.
Okay.
Based on the time of day.
You're not basing it on a curved atmosphere, right?
It has nothing to do with the shape of the atmosphere. This is just.
Well, what I heard was
I'm not done explaining what you're looking at. So just wait, okay? Got
Dude,
it?
you're stuck on a fucking sphere, bro. You won't even model it on a
nothing.
planet or
This has
concave Earth.
nothing
That means
to
you're
do.
not even worth talking to, bro.
This has nothing to do with the shape of the Earth. This is strictly about the.
He doesn't want to listen to it, does he?
The measure. No. This is
stop you, dude.
This is the measured coefficient of refraction over time.
On a curved atmosphere, bro.
It has nothing to do with the shape of the atmosphere.
Good to know.
This is the measurement.
So they're doing it on a flat atmosphere, then, right?
It has nothing to do with the shape of the atmosphere. I think that you didn't hear me the 7 times that I already said it. This has nothing to do with the shape of the atmosphere. There's another time for you.
Fucking obtuse. Listen, if the sunlight is.
This is nothing to do with the shape of the atmosphere. This is measured coefficient of refraction. That's it.
Based
over
on
time.
What? Light? Based on light, correct?
It's light, how much it bends through the air between 2 different measuring apparatuses. That's all it is. That's all you're looking at.
Me? Are you ready to listen yet?
No,
Okay,
because
now,
I didn't finish explaining to you what it is that you're looking at.
Bro, you're preaching to me. You're chanting like a priest.
I don't care. I don't give a damn what you think. I'm explaining to you. I'm explaining to you.
Brian never listened.
I'm explaining to you these measurements.
You're
It has nothing to
explaining
do
what
with the model.
they did. You didn't do this, bro. So don't act like you did.
I don't give a damn that you don't care that I did it or not. It doesn't matter. It has nothing to do with the shape of the atmosphere.
Then what does it have to do with? It has to do with light in the atmosphere,
this
right?
This is the curving of the light through the atmosphere between 2 different.
It doesn't have nothing to do with the
Shut up.
atmosphere.
Shut up.
You said
Shut
it
up.
had nothing to fucking do
Wow.
with it.
Shut up.
Shut up. I think Toon's going
Shut
to
up.
be broken here in a
Shut
minute
up.
with brain leak.
Shut up.
You said the fucking curve.
McToon doesn't usually get this frustrated with somebody. I think this first time.
Shut up.
Nothing to do with it.
Shut up.
No, dude, you're not gonna lie
Shut
right
up.
in my fucking face, dude.
Shut up. Shut up. I'm explaining to you what it is. Shut up. I'm explaining to you what it is that you're looking at, and you won't shut. You won't shut your mouth long enough to hear. You are too ignorant. You are too ignorant to just listen. So shut up.
Bro,
and shut up.
Heard this 100 times.
Shut up. You've not heard this
I've never
once.
Heard somebody
Shut
say
up.
That it doesn't have nothing
Shut
to do
up.
with the atmosphere than that it
Shut up.
does.
Shut
I've never
up.
heard somebody lie in
Shut
the
up.
second sentence.
Shut up. Shut up and listen. Shut up and
Dude,
listen.
I'm not gonna shut
This
up, bro,
is
until you correct
this is
yourself. I'm
this
not gonna
is this
Shut
is
up, bro. I'm not gonna
strictly
shut up. You might as well kick me. I'm not gonna let you lie, bro.
This
you
is
just said
strictly.
It had nothing to do with a sphere.
It has nothing to do with the shape of the earth.
Then you said it's like an atmosphere.
I might be able to offer a bit of clarification here. So, we say that light is traveling through the atmosphere. That doesn't mean that it's based on that doesn't mean that it's based on a sphere. Like if I measure a ball being thrown through atmosphere, that doesn't mean that I'm basing the measurements of that ball being thrown through the
I've
atmosphere
read
on
all
a
that, and
sphere.
it has to do with a curved gradient, a curved pressure gradient, and he's not acknowledging it.
No, that's nothing to do with what
All right.
MC Tuna is talking about here. It's to do with how much light curves. It doesn't matter what shape the Earth is. It just
all right.
It's just the coefficient that he's talking about.
Yeah, all right. He's too stupid to shut his damn mouth. So I'll explain for the audience because he won't shut his stupid mouth long enough just to listen and
Bro,
learn.
why are you saying that, bro? You need to fix your
oh
statement,
dear.
dude.
All right. Shut up. You're too stupid, Brian, to even listen.
Oh, wow.
So listen up, Brian. I'll explain to you. You won't hear because you're too stupid to listen. The audience will listen. This is on my website at mctune.net/refraction. This is measurements of the coefficient of refraction. The coefficient of refraction strictly deals with the radius of the arc of light between two apparatuses, the source of the light and the receiver of the light. That's all it is. This is measuring the radius of that arc over time. This was done on a sunny day. You can see up until 6 p.m. and then later somewhere around 8:30, maybe 7 or 8:30, it dips down to the lowest coefficient of refraction. Then, after that, I don't know exactly what time the sun set, but it's right around there. The coefficient of refraction goes up sharply. The radius of the arc of the light drastically increases because of the gradient of temperature and pressure. Peaking at just under 18, it's unitless, so it's the K of 18 at, let's see, 12, 13, maybe 14, right? So that's, oh yeah, whatever time, I'm sorry. Peaking then, right? And then later it comes back down. So it peaks in the middle of the night there. When the sun is down, it peaks, okay? That's all I needed to say. And you were too rude to just shut your stupid mouth and listen. So I'll unmute you now, and we'll see if you, I don't even know if you're still there. All right.
Probably still going off.
Here we go.
No, I'm not going off, dude.
All right.
I always thought it was based on a curved pressure gradient. On a curved pressure gradient was my understanding of it. That's all I was trying to say. You wouldn't acknowledge it. What the fuck?
You were interrupting me.
It. You said it's not a curved pressure gradient, bro. And I say yes. It's based on the globe model curved pressure gradient.
Has nothing to do with the shape of the air between the two devices.
Nothing to do with the atmosphere, right?
All right, go ahead. Present your model based on not measurements.
No, dude, you're not even acknowledging. I mean, I will present the model, but you're saying so it wasn't done in an atmosphere? It wasn't based on the atmosphere? The curved pressure gradient, bro.
Go ahead.
Oh, because it's got the word sphere in it, so it's atmosphere.
All right, I can take a picture and send it. But anyway, so the math is this, okay? So here's the math, okay? The math is 100% at 1 degree, like I said, 99%.
100% of what?
90.
What?
100% of 6 inches per mile squared. So here's what you do. What you do is you base your mileage. Let's say, just take an easy. Let's say.
What does this parabola have to do with anything?
No, that's just how it mapped out on graph paper. Okay, so check this out. So you take the distance of Polaris. Let's say we're at 15 degrees latitude. Okay.
Okay.
So that puts
later, Alan.
That puts Polaris at what? 15 degrees in the sky, right?
Yes.
Yeah, his boss is there.
Amazing. It's actually the opposite.
Okay.
It's 90 minus 15. But go ahead.
Yeah. It's opposite. So what you do is you
which would be what? How much is that?
Your distance. You get your distance.
75 people.
75. Get your distance. So
there you go. Good job. Do the math.
Dude, if you're gonna be a smart ass, bro, then why am I going to tell you?
Be a smart ass.
You're just here for entertainment.
Yeah. Well, fuck off, dude.
I know what to do. Oh my God. I know what to do.
Okay, what you do if you want to? Okay, so what you do is you take and get the distance.
Is that coming from Brian Leakey's microphone?
Probably.
In the background, yeah, because that's McToon's going. What's?
I think it's one. I suspect that's one of his grandkids.
Right.
Between that latitude and the North Pole. Okay.
Okay. I'll draw it out. You keep going. I'll draw it out.
So just divide it by. Huh?
Nobody knows.
What?
Yeah, just draw it out. divide it. Hold on, man. I'm being distracted. Hold on.
You're being distracted.
Not distracted. I can't call my grandson a distraction, but anyway. Okay, so you figure 6,100. Okay, so divide 6,100 by 15.
How's that?
Divide 15 by 6,100. Let me see. I can't see it.
If he's on his phone, he can't see jack shit.
He's always on his phone.
I can only see it on stream, not on. I don't know if you have your camera on.
Oh, am I?
Yeah, make yourself bigger, Tony.
Oh, did I turn? I turned off my camera. Hold on. I'll turn my camera back on.
Okay. So yeah. So you get your
have
distance.
it on yet. There we go.
So the
Okay.
distance. So I'm asking that you get the distance based on 6,100 miles from the North Pole to the equator, which is pretty much matches up with the globe. Okay.
Pretty much. Okay.
Okay. So now hold on. Give me 1 second.
It's yeah, okay. It's 10,000 kilometers or 60 times 90. 5,400 nautical miles.
Yeah, well, I did it. I didn't do it in nautical miles. Hold on a second.
I can do it in imperial miles.
70.
It's I like to do it in starting in nautical miles because the math is so much easier. 6,214.
Okay, hold on.
$6,214 miles from the North Pole to the equator. You doing some math?
406.
All right, hold on. I got a couple things to read. Hold on. We got a listen that said, just joined in. Might as well bring up the classic. Why is all navigation based on the globe? Also, Flatty, shut up when you're being educated for free. Walk, what's it like down there? Is it cold?
Down in yeah, it is. Well, that's why I put the jacket on, because it is getting rather cold this time of year. Although I have been told that the temperatures we get down here are nothing compared to the temperatures you get over in America or Canada during the winter. Apparently, you guys have much. Apparently, it gets into the negatives, more than negative 10 degrees.
Yeah, negative 30 Fahrenheit is we usually get a couple days under there in the winter, like overnight.
But what's that in proper units?
I only know freedom units for temperature. I can do.
I want that in Kelvin.
I can do. Wait, I'm only gonna do Fahrenheit based absolute temperature, which is it starts with an R. People, what is the Fahrenheit absolute zero temperature? There's a name for it. I've never used it before, because if you're gonna go to absolute zero, you're always in Kelvin. But
yeah, I do actually work in Celsius. Like here, it's sometimes I think it just gets to like -1 or 2 here at work.
That's it. So it's it says do it in sheep units. There's
4 degrees Celsius
sheep
right
units.
now, but that is 39 degrees Fahrenheit.
Oh, that's nothing. Well, that's nice. That's toasty. There, Rankine.
Added to
I haven't
surveys.
I haven't received a survey, so.
Well, get a transit, bro. Get a laser. Go. Just go. They'll say you're curving around the globe, but you won't read that.
All right. Sorry. Life in the northernmost cities and towns. So we got this Nye Alsund, which I probably mispronounced. Is a far north city. Let's call Mark.
It's a hole.
A
hole.
Yeah, I don't know what it's called. I'll just call it like a halo or something. It's like a little
There
halo.
you go. All right. So we've got Alsund To the North Pole, 1,904 miles. All right, so we've got that. Now what?
What country is that in?
Norway.
I did mine in Canada.
Okay, so we'll do that next. So now what do we do?
Get a couple more, and then write it down. Check the distances. And,
which
what
one?
What was the latitude of that city?
Oh, I'll write that down. It's 78 degrees, 55 minutes.
78. Okay, so multiply 69 times 12.
Well, it's closer to 79 because it's only 5 minutes off of 79. So what do you want me to do?
Okay, so multiply 69 times 11. It's 69 miles per degree, right? So
Yeah.
multiply 69 times 11 and tell me what that is.
759.
Okay, so 759 miles to the North Pole, right? According to the 11-degree Polaris, but it says 1,800. Now, you don't got to do any more, bro. Just trust me. It shows wild inconsistencies, bro, up there.
Yeah, all right. So here, let's look at this here.
That's only off by 1,000 miles, no big deal. I'm just joking. Calm down.
Yeah, now the problem is that this particular one is using a different latitude. It's using 62 degrees 28 minutes for the latitude. So
That's off the other way, but yeah,
I have a feeling that it's not using like and here's probably what you found was that you happily used different measures without really verifying that they were using the same measures. So on Wikipedia, it says Alsund is 78 degrees, 55 minutes. On this one that says the distance, it says it's 62 degrees. So it's off.
Okay, so multiply 28 times 69.
Off by, all right, it's off by 14 degrees. But that's fine. All right.
That's a little closer. That is a little closer. That is a little closer. But my whole point is...
Hold on. I'll do it right now. It's 62 minutes, or 62 degrees, 28 minutes. That's about 62 and a half, right? So we go 90 minus 62.5, right? We've got 27 and a half. Then we multiply that by 69, and we get 1897.
Well, still off, right?
No.
Not much. It's closer, but here's my whole point. My whole point is
I double estimated. I went sloppy on the minutes, and I went
that's
sloppy.
one city, and you got...
Hold on. And I went sloppy on the miles per degree, because it's not exactly 69.
Either way, you already see an inconsistencies. I wasn't trying to stick you at this point.
I don't see an inconsistency at all. It's 1904 miles versus 1897 miles. It's a difference of how much? How much is that? What is that?
Okay, wait a minute. Wait. You just said it was at 79 degree north latitude. The first reading you gave me.
Yeah, the Wikipedia page said that, but when I went to a different page, it used 62 and a half degrees north. So
right. So that's contradictory information.
No,
I can tell you
exact. Here's what happened, Brian. Here's what happened, Brian.
For every city,
Brian.
you tell me the latitude.
Brian, here's what happened. The Wikipedia article gave a different latitude than the one that I'm looking at right now. That's why there's an inconsistency. Not because there's some inconsistency in the globe. I was smart enough to identify that there was an inconsistency in the latitudes in those two articles. I think you missed it.
Good. So you had an inconsistency in the latitudes, right?
But when I identified it and I actually used the math, they were only off by 7 miles.
Yeah, when you found the right measurement.
7 whole miles was the discrepancy.
Dude, it's like talking to a drunk block wall, bro.
Absolutely. Well, when you have a hard time talking to a smart person.
Bro, that's the definition of inconsistency.
7 miles because of the that I didn't use the exact measurement of 69 miles. I used 69 miles instead of the exact, and I used 27 or 62.5 degrees instead of 62 degrees, 28 minutes, 20 seconds. That's what happens when you do some rounding.
Okay.
So there you go. We found
So
no
we got some-
inconsistencies so far. So where is the actual inconsistency?
No inconsistencies at all. None at all.
Absolutely correct.
So you went from 79 degrees to 68 degrees. No inconsistencies. Now check a couple other references. None of them are going to match up.
Show me. All right. Tell me the inconsistency that you found.
This isn't even my argument, bro. I didn't even make a video on this. This is just what I observed.
all right.
Cross-referencing out latitudes, bro. Okay. Your very first check, you got inconsistent corresponding.
And here's what happened. I used it's a different town. It's a different town.
Maybe so.
Yeah.
But
So I found no inconsistency. So you tell me where you found the inconsistencies. Go ahead.
The whole point was we're talking 100 miles. My latitude,
7
mine's
miles.
based on a circumference of 24,000. I based it on 28,400 mile circumference. Okay. I just basically divided that in 4. Okay. So if you divide that in 4,
all right,
you get 6,100.
Present your model, whatever.
Point 1. Okay.
Your audio went funny. All right, let's go with this. NA for $2 says I probably need another drink. And Alyssum says 0 degrees Kelvin is a state in which all energy is at 0. Then a flat.
I don't know if he comes back on
gets
again.
The higher up you go.
No, he doesn't.
Subtract. So Polaris's elevation is 3,655 minus 880. Hold on, I'll tell you what that is.
King Crew, I don't know. All right, Gowdens.
Okay,
I have no idea what he's trying to do.
The 2,775 miles, okay, would give you what degree? They give you 45 degrees. Hold on. I fuck this up every time I do it live, dude.
You should just write it down.
I'm sitting there, I did every single fucking degree from 0 to 60. But then when I do it live, dude, and I don't have it in front of me, dude, I fucking always fuck it up. But anyway, here's the point. So the point is you get the distance based on 6,100 from the North Pole to the equator. Okay, you do that by dividing 6,100 by 90, and then multiplying that times the latitude you're at. So if anybody wants to do this later on and check it, whatever latitude you're at, 6,100 times divided by 90 times the latitude you're at. So if you're at 45 degree latitude, then you get 3,050. So it's square that. So it's 6 inches per mile squared. Okay, so you square 3,050, 3050 times 3050 times 6 inches. Then to put that into miles, it's in inches now. So to put it into miles, I'm gonna divide it by 12. Then I'm gonna divide it by 5,280. I don't know if there's a quicker way to do that, but that's how I did it.
Maybe.
So then
I don't know where he learned math from.
Okay, that's your refraction right there.
880.
I mean that's what you take off. That's what you subtract from your latitude, basically. You're going to subtract 880.
All right. So my latitude is 45 minus 880.
So subtract 880 from 3,050.
Where did the 3,050 come from?
That's your distance.
My distance.
From where to where?
That's your distance to the North Pole.
It's 3,105 is my distance to the North Pole.
Well, I figured it as 3050.
Oh, you rounded. You just okay. Hold on.
Yeah, I kind of did.
No, 69 times 45 is 3,105.
Anyway, subtract
3,105.
Subtract 880 from 3050 because that's what we did the math on anyway. We could argue the semantics.
Okay.
Later.
All right. 2,225.
Hold on. 3050.
Plater Mark, I hope you're following along.
No, I'm just doing my own thing.
He's
just doing his own thing.
No,
Okay,
was
now
listening
to
to
get your
my
degrees.
video.
Okay, so what's your angle to Polaris? If it's 3,655, put it in a triangle calculator. If you want, I could do it. But so figure 2,170 is your and then figure your height. So your angle. We're looking for angle theta. But what
Clive
we
says
have
then
now
subtract
is we
then
have,
subtract
we have the
then
bottom-
subtract the
bottom
number
line.
you first
You go
thought
to the
of.
right triangle calculator.
Yeah.
I got a brand new piece of paper for you. Okay, here's the triangle.
Well,
Okay,
you've already, yeah. Okay, so the bottom line is what we just came up with, 2,170.
Why is that?
Because that's your distance. That's your new distance. That's your new refracted distance.
Why do I have a refracted distance?
Because that's the way light refracts on my model.
Distance?
What?
Okay.
Anyway, once you do this, you can do every one.
The distance doesn't change with the refraction, dude.
Especially with a calculator.
All right, so I got
Oh
this.
my god!
Okay.
Must be one of the dumbest things I've
Okay,
heard.
so angle B is okay. We don't know the hypotenuse. We're looking for the hypotenuse, and we're looking for the theta being your location. Okay, so the height. So the small side of the triangle is the height is 3,655 miles. That's the height to Polaris.
Okay, got it.
Okay, so
Right.
you have two sides, right? And you have your 90-degree angle. So calculate theta.
Oh, you want me to? All right. And then that'll tell me my latitude.
That should come out to 45 degrees, or
right,
pretty close to it.
let's-
Pause it for a moment, Terry, please. All right.
Okay.
I think what these flat earthers fail to comprehend, and they're arguing about latitudes here, is what the meaning of the word latitude actually is. Ultimately, the latitude has nothing to do with where Polaris is in the sky, etc. The latitude is the measurement of the angle subtended at the Earth's center. All right, that's the thing. It's the angle subtended at the Earth's center between your location on Earth and the center and the equator in the center. That's what latitude actually means as a way of three-dimensionally locating yourself on a sphere. They argue this latitude business as if they can talk about a latitude on a flat Earth. I mean, he keeps on saying 45 degrees, 60 degrees, or whatever in latitude, but what meaning does that angle have on a flat Earth? What is it the angle of? It makes no sense. Like, where are they measuring this latitude from on a flat Earth? You know, he's relating all this to like where Polaris is in the sky. That's a way of knowing where you are on Earth, like knowing what your latitude is, but it doesn't go to the deeper meaning of what the word latitude actually originates from, what it actually really means, what the measurement's describing. There, I've had my rant.
Okay.
I have a bad feeling about this.
Same here, honestly.
Okay. All right, hold on. Just so you know. All right, hold on a second. People at home following along. Here it is. 2,170. 3,655 is expecting this right here to be 45. Anybody
5
have any
degrees.
predictions? Hold on.
Oh, wait. Hey, I think I'm supposed to subtract. Hold on.
He's mucked his numbers up and you can't work out how.
Oh, you're gonna have to do all that again.
Well, just double check. But hold on, I'm double checking.
I don't need to triangle calculator to know it's not going to be 45.
It's quicker, bro.
Exactly.
Oh my goodness. All right. Hold on a second. Professor Phil Bell, could you please remind Brian that there is an F in the middle of the word 50? He sounds like he's saying 50. For example, he says 55. Can you say... Hold on, Brian, can you say 55, please? Hold on, first, planar walk. in your best Queen's English, because the Queen is still the boss of you, say 55.
55.
There we go.
Yeah, listen. Wait, take that
Brian,
sum. Wait.
Brian.
Wait.
Even though the Queen is not boss of you, can you say 55 in your best Queen's English?
Yeah, 55, but subtract the sum from 3,655. I was supposed to subtract the sum from Polaris, from the angle, from the height to Polaris, not the distance to where you're at. I don't know why I even did that. We're 6 inches per mile squared.
I don't either.
The percentage of from the horizon to Polaris. So subtract that last number from 3,655, and it's spot on, dude.
What number? Which the
third
20,
time's a charm, bro.
The 2107. I'm supposed
He's
to.
got one of his numbers wrong.
No, hold on. Okay,
There's no way you can get 45 with those two numbers.
Okay, so one last time. Okay, so 90 divided by, 6,100 divided by 90.
Yeah, I'm not doing it, but you just do it.
I'm doing it. I'll just. You'll remember the number, but 6,100 divided by 90. Okay, times 45. Okay, times 6, which we left off earlier. It's 6 inches per mile. Okay, times itself. So times 18,300. Okay, now divided by 12 to put it in feet. Now divided by 5,280 to put it in miles.
Thurston said, I've got to read out Thurston's. Brian came up with a calculation to take your latitude and return your latitude back out. His resulting latitude had increasing error from North Pole to equator when it was 14 degrees out by my calculations. Okay. Heat shield says 6,100 divided by 90 times 6 times itself. Okay. I used the equinox sunset and Brian's method to get the sun elevation, and then get the sun angle at equinox noon. It was about 10 degrees out for the UK and Sydney, Australia.
Miles. Hold on, goddammit.
I'd actually be very curious to find out what his calculations would be for me in New Zealand.
Yeah.
For this sun.
I ain't got that far yet. Bro.
Is your model not do that?
50. Okay, hold on, not yet. Okay, times 6 divided by 12 divided by 5,280. Okay, it was 880. So our sum was 880. Does that sound familiar?
Hold on. People are wondering what your name is. Well, introduce yourself again, because there's some new
Flat
people.
Earth Test. If you want to see my videos, go to Flat Earth Test. All capital caps are at the beginning of each word.
It's
Flat Earth Test.
Brian. How do you say your last name, Brian? I don't want to say it wrong. Leakey. Brian Leakey is his name.
So if you want to see my videos, go to Flat Earth Test. But listen, so 880 was the sum, right? So subtract 880 from 3,655, because that's the height to
That's
play.
your math, Brian. That's us what.
So, wait, 3,655 minus. Hold on, I'll do it. 3,655 minus what?
Hold on. That still doesn't work out, but minus 880. Fuck it, I done.
It still doesn't work out.
Something, man.
That's an understatement.
Yeah, I get 2775. That's not gonna work either.
No, it doesn't, man. That's closer though. Well, maybe the fourth time. Nah, fuck it, man. I gotta redo this, man. But dude, I did it.
Tell you what. Let's go full.
Wait. We can do the percentage, Michael. My percentage. Okay, so 45%. Okay, at 45 degrees, it's 60. Wait, it's 60%. That's the whole model. It's 60% of that number. It is. Yeah, I know, dude. 60%. What's 60% of 880?
Right.
I know. That's the whole model. I almost forgot it.
Birth, it's back engineer
60% of 880. 528. 528.
Okay, now subtract 528 from 3655.
All right.
Yeah,
3655
Yeah.
minus 520
Was it 520?
528 is 3,127.
Well, you're going to get right about 45 degrees. It's like 45.2.
All right, hold on. 3,000.
It's 528. Mine's 528.
This is our new, right?
Yeah.
Okay. And then we want to solve for theta here, right?
Yeah, so you got 2,500
and I'm in Minneapolis, where the angle to Polaris is 45 degrees.
Yeah, so 3655 minus
Okay.
528
I'll just
3,120.
I'll just plug that into a calculator here.
Yeah.
Planer walk. Are you feeling optimistic?
I'm not feeling optimistic. Like, I'm
think
just
about it.
thinking maybe I wonder if Brian do you know what Brian looks like, MC2?
I think I've seen him.
Why?
Does he
Why
look
are you
like
worried about
Jason
what I
at all?
look like, bro?
No, he doesn't look like Jason.
Okay.
Why you want to know what I look like, bro?
Because you sound.
If you want to see what I look like, go to Blue Marble Science.
You sound. He thinks you sound handsome. That's all.
Yeah.
No,
look,
I'm
go
just saying that
to Blue
I think
Marble
you
Science
sound.
on the front page behind Cleary on
The
Blue Marble
things you-
Science video.
The things that you say sounds like what Jason would say. Like maybe you're just Jason with like a. Just a thought.
Okay. So here we go. We've got so we're trying to solve for angle theta, which is in this calculator is alpha. So alpha, we've got 49.452 degrees. So you're off by more than 4 degrees, Brian.
No. Hold on. 880. Wait, hold on. It's not that much. Okay, wait. You're at 3050, right?
I'm at
according
what?
to you're at 3,050 miles. Okay, according to our calculation.
I'm 3105 measured miles from the North Pole.
Okay, so and what number did you just wind up with?
49 degrees. 49
No. I'm talking about. It was 3127 was the height. The new refracted height was 3127. So
Yeah.
what's your distance again?
3105.
3105. So that's within 22 miles, bro. What are you talking
Yeah,
about?
the problem is that if we put in the measured distance of 3105 and your claimed elevation of the sun of
3050, I meant. And in fact, I got it wrong because I have everything based on
I'll give you a little hint, Brian. Yeah. On a 90 45 45 triangle. The opposite and adjacent have to be the same.
I understand that, bro. I understand how they work.
In order for it to work from Minneapolis, I need to be 3,655 miles from the North Pole, which I am not.
Yeah, but from the North Pole to the equator, okay, so 3,050. Let me try it one more time because, yeah, right now it's off a little bit, but not that much. It's not off as much as you're saying because if it's 69 miles per degree, then it can't be off more than 2 degrees. Wait, 30, 50. Wait, 30. It can't even be off by more. It can't even be off by a full degree, McToon. Think about it. If the distance,
it better not.
Jesus. I was looking for the Walmart. I'm only 150 miles off. Shouldn't be a problem.
Not be, but so far you're 4 degrees off right now, so you got a lot of work to do.
No, it's not. Double check,
Brian. Here's a suggestion.
Wait. Double check your math because
This is so typical of Brian.
Yeah.
Brian's basic idea was to calculate HR or something, reduction in Polaris height, pH, based on your distance from the North Pole, dn, such that arctan... Is that all math, is it, Thurston? I'm not good at math. Sorry.
Listen, if it's
I made up shit and it almost works.
69 miles per degree, and my final answer was
I didn't.
3,001.
You did all.
That's only off by what 57 miles?
You did all the math, not me.
Yeah, I know.
Hold on a second. Oh, this is awesome. It's so funny. All right, sorry. I love you, Brian. You're great. All right. Chronic Avenger is asking, how much does the light curve at the maximum refraction point on your model? Now,
100% of 6 inches per mile squared.
PhD Tony comes into it after that, so I'll probably just jump ahead to that, a bit of that.
And by rainforest, okay? It's created at the ground. It's cycled at the ground.
Here's the deal, Brian. Pressure
you can deny it.
Pressure disequilibrium equalizes at the speed of sound. If that were the case and there were no forces involved, then there would be an upward wind at 700 miles an hour or more.
Bro,
there is not.
There's a constant upward wind over the ocean, and albatrosses fly for up to 2 years without even flapping their wings, bro.
2 years? What an albatross? Did you say an albatross for 2 years can stay flying? That's a long time.
Albatross.
Laugh all you want, but albatrosses stay out at sea for 2 years.
Oh my gosh.
You can laugh at it, bro.
Welcome, PhD Tony. I'm glad to have you.
You're funny as shit when you're drunk, bro. I'll give you that.
Hello. Hello. Greetings.
Okay, wait. You realize 6 miles is a long way away. And this oxygen, hold on, all this oxygen's coming from rainforests and plankton blooms, okay? And it's making its way 6 miles. It's making its way even higher than that, okay? But if you know anything about refrigeration, you'd know that where the gas is created, okay, there's going to be more pressure, okay? And as it expands up and away from the ground, which it does, which you've already admitted, it cools down, okay? It doesn't matter. It's getting closer to the sun. It's expanding, so it's going to cool down. Just like it gets colder and colder the higher we go.
Heat shield's saying to speed it up, but Brian talks so fast, it'll just sound like more garbled.
Okay, if you look at the Soundly rockets, you'll see that the temperatures went down to negative 252 Celsius, right by absolute zero, where helium turns into a superfluid, bro. We already talked about this on the last stream, and his own guy called in and told him he's wrong about the pressures and the temperatures and shit. He didn't want to acknowledge it.
So do you think I could say something?
Yeah, go ahead.
Okay. Do we agree that pressure is equal to force divided by area?
Well, can you show me a citation that pressure?
Can you agree? Can we agree with the definition that pressure is force divided by area? That's a yes or no question.
I'm not going to ever answer a yes or no question, but this is all about refraction. Show me that pressure causes refraction. Show me a citation that pressure causes refraction, please.
Okay. Would you agree that the shape of the planet is completely independent of the refractive qualities of air?
Bro, a statement without evidence will be dismissed without evidence, okay? Show me where pressure creates refraction, bro. This is all about refraction.
No, it isn't. This is about the shape of the Earth. So. This is about the shape of the Earth, right? You would agree that the shape of the... So you said it earlier, optical observations are influenced by refraction. And there's a lot of discussion. There's been a lot of, to my mind, pointless back and forth about refraction of light.
I'll agree with that. I'll agree.
As it travels through air, right?
Right.
Okay.
Here's the whole debate, to put it in a nutshell. Either the ground's curving or the light's curving.
Okay, so let's look at a different source of data, right? So let's,
they're both upside down.
Light, which has awkward properties that it travels through.
Okay.
I won't accept any citation or any bullshit without demonstration. I can show you a pressure gradient in containment. I did it on my video. It's very easy. Hey, you show me a pressure gradient without containment. It's easy to demonstrate in containment, but you can't do it without, bud.
In fact, I can. All that is necessary is for there to be a pressure gradient. Now, in your case, the pressure gradient is applied by the reaction force of the container. But again, you keep on interrupting me. Let's look at the propagation of sound through the earth, right? Seismic energy. Let's consider that
this will lose
as
Brian.
a data source. Now, you will accept, obviously, because you have a good understanding of physical science, that we can determine the
waves to
internal
do with
characteristics
earthquake,
of a material object
seismic,
by transmitting sound through it. It's how ultrasound works, right?
Bro, what are
It's
you
how
talking
they
about? Let's go to sonar. If we're going to do that, let's go to sonar. How do whales hear 4,000 miles, bro? It's crazy.
Okay. You are changing the topic every time I want to establish a topic.
I don't know physics. I know common sense, bro. If whales can hear
so
shut up the argument, bro.
So no, it doesn't at all.
Have you ever heard of an acoustic shadow? Have you ever heard of an acoustic shadow where submarines can hide behind things because of acoustic? It's called an acoustic.
Is this the only time that I've actually seen or know of a person where Dunning-Kruger is the actual description that fits the person down to the T? A real life one, that is, not just in theory.
Other than Bev earlier on.
Well, other than Bev, yeah.
Yeah.
But I think Brian Leakes, I think he's on top of the
shadow. Whales can hear each other over 4,000 miles, bro.
Yeah, that's because.
Thanks for interrupting me.
Well, I got the impression that it was okay to interrupt because you'd interrupted me about 5 times. I've only been here 5 minutes, and every time, yes.
If you want to be a lying sack of shit, dude, I ain't interrupted you 5 times. This is recorded.
You have interrupted me 5 times.
Every time I fucking talked, you've interrupted me, you asshole.
No, I have not.
This is recorded. You understand?
Yes, I understand that it's recorded, and I'm more than happy to go back through the recording.
You have interrupted me.
No, actually, it's exactly the opposite. I asked if I could talk. You said yes, and then as soon as I started talking. Okay, well, you're making an excuse to rage quit, aren't you?
No, I'm
you're
not
just prepping the ground here. Yes, you are.
You just asked me a question, but now go to answer it, and you keep talking. No, I'm not rage quitting. Now,
you understand that I am in the southern hemisphere, right? You understand?
Talk to a liar, dude.
Do you understand that I am in the southern hemisphere? And confine yourself to yes or no.
There's no point in fucking answering, and I don't answer yes or no. If that's what you want, get somebody else. That's the first time you let me finish.
Okay, I'm in the southern hemisphere. Do you understand that it takes some... Okay, you don't understand. Fine. Then I will explain it to you. It takes some time for the signal from your computer to reach my computer and to go back to you. Because I am not in the same fucking... I am not in the same... You just interrupted me, you rude motherfucker. After calling me a liar like a dozen times because you keep on fucking interrupting me, you then have the temerity to interrupt me while I'm explaining something that you just said you didn't fucking understand.
Calm down, Cletus. I'm just fucking with you.
Oh, jeez.
I'm sorry that you find that amusing. It is clearly amusing to Toon, and I can understand because he's not here. But you are really trying to obstruct this conversation from being anything even approaching constructive.
Maybe so, but I guarantee you when you watch this later, when you ain't heated, you will get a laugh out of it, dude. I promise you.
Maybe so.
No, he won't.
Check this out.
Do you wish to learn anything?
Yes, I do. Yeah, yeah. I'm always able to learn.
Okay, so You understand that there are seismic events, like events that cause propagations of energy through the Earth, right?
Yeah, yeah. I'm to the understanding
Okay.
that yeah. That sounds travels faster through solids, right?
Yes, that's right. So there are particular types of seismic, and we can use the travel times of seismic waves to make predictions, right? So if there's an earthquake at one location, we can work out how fast that energy will take to travel to every other point on Earth, right?
The PNS waves.
PNS waves, and there are also a lot of reflections. So there's PKP
What map are you
waves.
going to use to chart them, though? I see what you're saying. To me, it's not 100. It's good evidence for a globe. To me, it's not 100% proof because the map, you got to use a certain map. If you use the AE map, I could prove it's flat. If I'm chart PNS waves on a flat map, I could prove the ground is flat.
No.
No, they don't work on a
So I
flat
have
Earth.
actually done this demonstration for the
Yeah.
Christmas Island earthquake from the, and I've done a video on it. And if you do an azimuthal equidistant projection that is above the focus of the earthquake, you can see that the arrival times just spread out in a circle. It's like watching a ripple spread across a pond. But as soon as you go to an azimuthal equidistant map at the north, centered at the North Pole, then you've suddenly got the fact that the seismic energy has moved from one side of the Earth across to the other side of the Earth without passing through any of the intermediate material, and that in order to travel that distance, it would have to travel at much faster than the speed of sound.
I got two questions, and they're both serious, so don't think I'm being sarcastic.
Yeah.
The first one is this, seriously. Okay, are they spreading out in great circles? And number two, are you sure they're spreading out are you sure if they're spreading out equally in a circle? I mean, couldn't they be going in a circle on a flat Earth map? Wouldn't it if I mapped the longitudes not converging?
So the answer to both questions is no. So if you map them out in a, they don't. They've got nothing to do with great circles. It's just distance away from the center of the point. So it's just radiating out. And the other element of the question is no, it doesn't work on a flat Earth. Now there is another element to this. There are particular seismic waves called Rayleigh waves that are surface waves, and they're highly energetic and they're very coherent. And they actually, for large enough seismic events, they go around the world multiple times. Okay, and so if I've got an earthquake at one point and a seismic station at another point, now the Rayleigh wave is going to go from that earthquake. It's going to hit the seismic station, and then it's going to go and do another lap, and it's going to come back. But even more than that, there's a Rayleigh wave that went in the opposite direction that has come around the back of the Earth and hits the seismic station, and that's going to keep on going around, and it's going to come back for multiple orbits. Now that doesn't work on a flat Earth. That cannot happen on a flat Earth. If you go out and you're about to suggest that it can just rebound off the edge of the disk.
No, I'm not. I'm not going to suggest nothing, but I do have an idea.
Okay.
But yeah, go ahead.
Okay. But it can't rebound off the edge of the disk. If it rebounds off the edge of the disk, then the repeat times would depend on the proximity of the receiver to the edge of the disk, rather than just its angular distance from the earthquake. And that's not.
So how are you distinguishing the reverberation from the lapse?
So there are various ways of doing this.
Nothing proven.
If there are, I beg your pardon?
No, listen, here's the thing. Okay, so when I was just looking up the Earth and everything, I went to the surveys and they were talking about how the South is bigger, how the elevation at the equator is 20 miles bigger. And I went to the GPS, okay? It's a Navy video. Go to Flat Earth Test. I'll try and make this short. But you can see where they was mapping out the world with their first satellites and all this and that. And how they showed the Earth. And they did show, in fact, it is pear-shaped. The southern hemisphere is bigger. They show them a piece of it. This is a 1965 or
So how's this relate to earthquakes?
Navy documentary. It shows a pear-shaped Earth.
Sorry, that was
I'm
me.
echoing.
That was my fault.
Anyway, it's showing a pear-shaped Earth, and they're saying the southern hemisphere is bigger. And to me, you know, in the northern hemisphere is smaller. Okay, so even on a globe, on your globe, if you get right down to the actual measurements, it's bigger in the south and smaller in the north. But on top of that, how could they fool people? So surveys, they would have to have it get smaller in the South Pole going away from the equator. So they add 20 miles of elevation. So if I'm surveying and I'm going to be like, hey, what the fuck's up with this, dude? This is not working out. They're going to say, oh, no. The equator, since it's spinning, it's 20 miles, it's 20 extra miles of elevation at the equator. I mean, it just all sounds like the best they could do, good estimations. It's a great model, bro. I'll give you that,
Okay,
but it's
so
converge.
So actually, I work with two of the people who developed who helped to develop the Gamut software, which is the MIT GPS software processing package. And in order they use it to identify the motion of plates on Earth's surface and to provide magnitudes for those. And actually, they've made some progress in working out regions that are at high risk of earthquakes, because actually if there are two plates moving in opposite directions and the bit between them even isn't moving, then you can tell that the stress must be building up there, and so that area is at high risk of earthquakes, which is something that they've been able to do. You know, they made a prediction that this area would be at high risk. Somebody built an oil pipeline straight through that area, and the pipeline got destroyed by an earthquake that these people actually predicted was going to happen. So yes, the people who are using this GPS technology, in order to get really accurate, results, they have to solve for the geometry of the entire network, which is to say all of the satellites plus all of the receivers, and they need to include the ionospheric corrections as the radio paths.
Ionospheric diffraction, right? Let me ask you one more question. Right. These are serious questions too. So when they're judging by their satellite's orbit, then the satellites are curving around the Earth. They're basing the satellites as curving around the Earth.
That's correct.
Okay, so if they know for a fact the satellites are curving, then their ground's going to curve, and all the maps are going to match that. Okay, but before they did that, before they did any of the time dilation, they used their calculations. They used the ionosphere. They use ionospheric refraction, okay, and they say that the ionosphere is refracting the light, okay, but if you took away, you could have argued a flat plane. Now it ain't flat, but a level plane for the most part, without the bending of the light in the ionosphere. So that's what I meant by my model being kind of ad hoc, because a lot of the globe models are ad hoc. But I would be very interested in looking at the seismic activity. But once again, it's based on converging longitude lines. So anything you map on converging longitude lines, including GPS, you can't use GPS to prove GPS. That's all I'm saying.
Okay. So that's well, fair enough. I mean, that's but yeah, are you familiar with the Haversine formula? Right, the formula for the distance between 2 points on Earth's surface. The point for
that. At what point would it become? I mean, without doing the math, at what point would it become like obvious? I mean, it's a pretty damn good distance, from what I've looked at. What would be your estimation of what distance would it become obvious or apparent?
The difference between the spherical distances and straight line distances. I suspect you could, about 200 miles. It'd be really obvious over that sort of distance.
That's all right. That's bold, but yeah, you know the math better than me. I wouldn't at that. But okay, now what I request you do. This is a personal request. You don't have to, but look at the data if you have access to the satellite data, and just entertain me and just mathematically do it as a circuit, or and check out the refraction, the ionospheric refraction. Compare that to the what do you call it? What you call it for me? The Haversine
formula. So We actually, that's actually part of my job. So I work on a slightly different satellite mission. So I work on the GRACE data, which uses gravitational attraction due to surface mass concentrations. Now what we do is we've got two satellites, and there's a laser shining backwards and forwards between them. Now, if you imagine those two satellites moving across the Earth, it doesn't matter if the Earth is flat or round for this sort of visualization. If there's a heavy mass,
you need one more satellite, man, to put in the middle. Not good.
Okay, well, the positions of the satellites are recorded in connection with the GPS.
Yeah, I'm with you, man.
They've got GPS. But what's important for our calculation is the intersatellite distance. So the satellites are measuring the distance from one to the other constantly using a laser. And so as the lead satellite, perhaps I'll use these bottle caps. If there's a mass ahead of the lead satellite, then the lead satellite, as it moves closer, the gravitational force is going to be stronger, and that satellite is going to move further. And so the distance between these two satellites,
a little so we can see them.
As the lead satellite is moving ahead, it'll experience a stronger gravitational attraction, and so it'll move away from the following satellite, and the inter-satellite distance will increase. And then as it gets past the mass distribution, it'll actually slow down, and this rear satellite will catch up. And then once they're both past, this rear satellite will experience a stronger retrograde acceleration, and so that lead satellite will move away again. And so there's this change in the inter-satellite distance that we can use.
I think we might leave it there, guys.
The force due to gravity.
Yeah, probably not a bad idea.
I think we've run a little bit over time tonight. Now that Alan's back,
Yeah,
I can hear him typing.
I was literally going to type a message in the chat, Terry, that I've got to go to work in 5 hours' time. So
yeah. Some of us have got a life.
Yeah, exactly.
Yeah.
Yeah,
Well, my steak and chips was very, very nice.
Steak spelt S-T-A-K-E. Is that a new type of steak? Is it?
I'm bloody dyslexic, and it doesn't have a. And it didn't get a red squiggle underneath it, did it?
He's a vampire, right, Terry?
It didn't get a red squiggle.
It didn't.
I knew it looked wrong, but it didn't have a red squiggle.
It didn't have a squiggle because it is how you spell steak.
Yeah, it is. Yeah,
if you're talking about a lump of wood you hammer into something,
yeah, exactly.
That's the problem with autocorrect. It doesn't necessarily understand exactly what version you bloody want.
Yeah, I know. That's how I ended up with Lego in my last damn video.
Instead of Lego, yeah. Yeah, because it goes Lego. What's wrong with that? It doesn't know that you want it to say Lego.
Yeah, and once it agreed that Lego was perfectly fine, I was happy with it too. It thinks it's right.
Yeah.
Need to teach spell check how to fucking read.
Yeah, that's the problem when you have the words that sound the same and spelled different, isn't it?
Yes. Yeah, that's the problem with the English language.
If you get the wrong one, it doesn't tell you. I mean, Rosie is severely dyslexic, and she can't actually use a spell checker.
Right.
Unless it only gives her... if it gives her... Well, it's all right if it comes up with one choice of word. But you know, like in Microsoft Office and whatever, sometimes it will give you sort of 3 guesses, won't it?
Yeah, it'll give you a choice.
Her dyslexia is so bad that they all look the same to her.
Yes, I can see the problem with that.
I always have problems with I's and E's in words like thief or sieve or something. I always forget.
Getting them in the right order,
Yeah.
Yeah.
I'm having a problem with my eyes at the moment. And the problem is trying to keep them open.
Go to bed.
Well, bugger off to bed then.
Yeah. I better type in me goodbyes out there while we say goodbye. Well, I hope everyone's enjoyed the evening.
Yeah.
Yeah, it was fun. I did watch the stream in the living room on the telly while I was eating my dinner.
Oh, I was you now. Okay. Brian Leakey at his best earlier on.
Yeah. I missed a bit while I had to supervise Sam cooking the steak, because she's even worse at cooking steak than I am.
Do you like it medium, rare, or?
I like it rare, but it ended up medium.
Oh, okay.
But it was fine. It was still. It was lovely and tender. So
yeah,
there was that.
Yeah, don't cook it too slow. Don't cook it too fast. Just cook it just right.
Tesco sirloin steak that came from Tesco's.
And how many times did you turn it over?
Oh, I think it got turned over 3 or 4 times.
Okay. I don't turn it over straight away until one side's sealed, until the blood starts coming out, and then when I turn it over, that's usually nearly when it's ready to eat. It'll serve up.
Yeah, you only need to sear both sides. That's it.
Yeah.
Don't take long at all. Well, you shouldn't.
Did you hear about the dyslexic atheist insomniac? He lay awake at night thinking about dog. Yeah.
Oh, thanks, Alan. Thanks, thanks, Paul. Thanks, Farmer. Thanks, Blue. You can keep talking. I'll thank John and who's out there? M2M. I don't like M2M. Space Mat's better. Clive Wells, Fred, Heat Shield, Dart, Astro, Flow Rider. I think Dora was there earlier. Elmigs. Who have I missed? Spooky. There's Thurston.
Heat Shield.
Heat Shield. Yeah, don't forget Heat Shield. And Carl wasn't here. Didn't anyone else notice that Carl wasn't here tonight? Out there.
It was noted. Yes.
Yeah, it was noted much earlier.
Dave Cannabis was there earlier. I said Spooky, didn't I?
Yeah.
I think Wally turned up earlier. He was there lurking.
He was.
Little Wolf, Fred. Yeah.
The two new peanuts that
I can't read them out because they're not showing up on my end.
Gone back too far.
Yeah, I can't go back that far.
No.
On my end.
Did you have Irish?
Oh, Anamorphic Mind. Stewie. Where was Stewie? I didn't see Stewie. His name.
Irish Stew was there.
Oh, there he is. Yep, there he is. I see him.
Loads of Motorheads things with him and one's death.
Yes.
I think Astro Rex. I missed that one. Who else did I miss? Dart, Demon Orb. So if you get in it now, I'll give you a shout if I've missed your name. Otherwise you'll miss out.
So, anyway, Terry, just a quickie before we all go.
Mm-hmm.
I left the Adderall in my Ford Fiesta. Now I've got a Focus.
Yeah, right.
Yeah. Oh dear.
Hey, nay. Yeah, that's everybody. Okay then. We'll see. We'll have to finish off what we were reading out earlier on. So,
yes.
So navigation type. That's the subject anyway. The generic subject matter. Okay. Oh, new video in about an hour and a bit for Space Matt.
Cool.
So the link's in the peanut gallery. Drop it in over in I think it already dropped in for you. I think you already put a link over there, Space Matt. I'll have to check.
Oh,
I know you put it somewhere.
I suppose it'd be better. I suppose it might be an idea if Space Matt puts the link to his questionnaire thing he wants to do about
about the thing.
COVID vaccines.
Yeah, the thing. Yeah.
Yeah, I did that.
He wants to try to get us so many numbers for it, so it would be good if we get enough for it. All right then. Well, good night, panel. Good night, Peanuts.
Good night, Peanuts.
Good night, everybody.
You're not playing us out tonight, Paul, or are you too tired?
Oh, I'm tired.
Okay.
Let's go to bed.
Have you learnt that? Have you got any further with that new?
No, I haven't even had time to look at it yet, Terry.
Okay, I'll ask you next week. All right.
Yeah.
Then. Later.